Hello everyone, welcome to the SpaceUp live stream. This is our third one. We're going to wait a couple of minutes just to let everybody else join, but there's already a few of you here, so welcome. Feel free to get to know each other in the YouTube chat, yeah, we'll get started in a minute or two. Hello everyone, welcome to the SpaceUp live stream. This is our third one. We're going to wait a couple of minutes just to let everybody else join, but there's already a few of you here, so welcome. Feel free to get to know each other in the YouTube chat, yeah, we'll get started in a minute.
Remco, I love the background you have. That's fantastic. Love that poster.
It's the World Space Week poster, so we'll be talking about that, but that's the official poster for World Space Week this year.
Very nice.
I didn't make it, but thank you.
Yeah, I was just thinking I need to, take a screenshot and stick it as my background.
Well, feel free. I can send it to you as well.
Yeah, cool.
Okay, we are live actually, so...
Yeah, sorry.
Okay.
It's fine. SpaceUps are informal, aren't they? They're all good fun. Shall we get started then? Thank you everyone again for joining this evening. We've got a fantastic lineup for you today. This is our third SpaceUp Live, and this one is a special edition for World Space Week, and we'll hear more about that as the night goes on. If you want to engage on social media, then there's two hashtags to know about. One of them is SpaceUp Live, and the other one is WSW 2020. So your hosts for this evening are myself. I'm Ryan. My background is in physics with space science, and I'm a software engineer by day, and also in my spare time I run R&R Space with the other Ryan.
Yeah, and I'm also Ryan, so that can get confusing. So yeah, my background is also in physics, astrophysics, and in my spare time I run R&R Space, but my day job is in the media. And next we have Remco. So hello, Remco.
Good morning, good afternoon, good evening, wherever you're dialing in from. I'm the third R, not Ryan, Remco. I'm the CEO of the SpaceUp Foundation, and in my spare time, I run a small media agency specializing in social media campaigns and marketing for space.
Fantastic. Thank you.
And so this event is being organised by R&R Space, so that's Ryan and myself. We new sort of events company. We're two enthusiasts trying to really change the nature of events. So rather than having massive sort of corporate events, we're trying to really engage with people, ideas, and skills for the sector.
You've gone mute again, Ryan.
Yeah, yeah, so next to Ryan.
Okay.
And yes, so we have SpaceBit, which is our sponsor for this event. So Pavlo should be joining us very shortly. SpaceBit are planning on launching a lunar lander next year. So Pavlo, yeah.
So this evening we've got a fantastic lineup for you guys. We've got starting off with a welcome, which is now, followed by an introduction by Professor Chris Welch. And then we've got a short talk from our sponsor, SpaceBit, followed by a short Q&A about that. And then obviously SpaceUp is your event. So we've got some fantastic talks which were submitted to us. We've got 3 grid sessions, more about what they are in a bit, and 5 T-5 sessions, again, a bit more about what they are in a bit. And we've got a fantastic panel session for you tonight as well. And we should be aiming to finish up about 7:30 tonight in UK time. So that'll be different times around the world. So the first kind of session is a grid session. And this is basically whatever you want to do with that time. It's 15 minutes. The common thing to do is spend 10 to 13 minutes talking, followed by a short Q&A. But you can do anything from a workshops, quiz session, anything you want. They're your sessions, your time. that's a good session.
And the next is the T-5 sessions. So each of the presenters is given 5 minutes. So this is on the clock. Ideally it's sort of 20 slides. So that's 15 seconds per slide. So this makes for a fun and interesting sort of pitch style talk.
And the last kind of session we've got tonight is a panel. As it says on the tin, we've got 4 panelists tonight. We'll start off by getting them to introduce themselves, ask them a few questions, but then it's over to you guys to ask some questions in the YouTube chat. Anything you want that's related to the topic. So yeah, it's your event. Ask some interesting questions. And then, oh, sorry. And then we've got Remco, I'll stop presenting, for a quick introduction, whistle-top tour of what SpaceUp is. Yeah.
Yep, there's the unmute button. When you go in presentation mode, the whole screen changes and then the unmute button is certainly gone. So yes, thank you very much. I would like to give you a very short introduction, less than 5 minutes, about what SpaceUp is. I do this in the beginning of every talk, just to give you a little bit of an idea about the type of event that you've joined. So a few minutes about SpaceUp by myself. I'm the CEO of the SpaceUp Foundation. Let me see how I advance my slides now. Yes. So first of all, what is SpaceUp about? SpaceUp is about bringing together your local, or in this case, your online space community. Be a platform for people who don't have traditional platforms at the big space conferences for whatever reason. And especially, this is what the founders of SpaceUp had in mind, is the most interesting part of a space conference often happens not on stage. So behind the scenes, where you meet people for water cooler talks, for coffee talks, during the receptions. That's often the most interesting part of a conference, why people go there. And SpaceUp intends to bring those water cooler talks onto the stage and make the networking central to the event. That's slightly different in a virtual environment than it is in real life, but I'll get back to that in a minute. So really, the objective of SpaceUp, really simple, is bringing people and ideas together with other people and ideas. Networking, getting ideas, ideation is what it's all about. A little history. SpaceUp was founded 10 years ago. So this is our 10th anniversary this year. The first SpaceUp Unconference was held in San Diego in the United States in 2010. This was really a response of people who were not happy with traditional conferences, wanted something else. We're looking at a concept called bar camps. Perhaps you've heard of that, which is still going on in other industries. And they decided to make SpaceUp the bar camp brand, if you like, for the space industry. It's gone, I wouldn't say viral, but I would say global, at least, quite over the last 10 years. The first event in Europe took place in 2012, which was a massive success, and really that set the stage for a global takeover of the SpaceUp Unconference brand all over the world. And we've had unconferences on all continents, including participants from Antarctica joining live from the Concordia station, for example. So what is SpaceUp? SpaceUp is a very simple concept. A, it's an unconference, and B, it's about space. And this is really everything that SpaceUp is. And if you look at the unconference concept, what does that mean? An unconference really is the same as a traditional conference, where everything is organized. You have a venue, you have a date, you have rooms, you have time slots, but you don't have talks. The talks themselves, the idea of a traditional SpaceUp is that the talks are brought in by the participants. Now, again, that's slightly different in a virtual world, but again, going back to what SpaceUp was founded for, is you have a minimum of pre-assigned speakers. Of course, you have a few sponsor talks, and you have a few very special people who want to join. Like in this example, we had the director of ESA who decided to join us. Of course, we gave this person a slot, but the idea is that a SpaceUp Unconference fills itself with talks by the participants. As I said, SpaceUp during a pandemic, slightly different. It's hard to bring people together in a physical venue. So now we use Zoom and YouTube Live and whatever tools there are for online SpaceUp events. We try to stick as much to those basics as possible, but obviously it's a little bit less spontaneous than a live SpaceUp event would be. But we do try to give everyone as much as possible a podium. It's a dynamic concept, really. And no SpaceUp is alike, and it's driven by the participants, like yourself. So anything goes as long as it fits these two very simple criteria, that is an unconference and that it's about space. So also the future of SpaceUp really is in your hands, in the people who are participating now, the people who have participated in the past, to pick up this idea and to organize your own SpaceUp event or SpaceUp Live event. So I'm really looking forward to seeing people staying active, keeping the SpaceUp brand alive, and organizing SpaceUp events around a theme or around a certain geography, around a certain language, whatever you want. We're celebrating our 10-year anniversary, so thank you very much to all of you who have participated in the past, who have organized events in the past. We really depend on you to keep this going. So thank you very much, and looking forward to the next 10 years. Of course, this week we're celebrating World Space Week, so happy World Space Week all. And back to you, Ryan and Ryan.
Brilliant. Thank you very much, Remco.
So next we have Professor Chris Welch, who's the Vice Chair and Board Member of the World Space Week Association. So over to you, Chris.
Okay, thanks, Ryan. Just let me share my screen. And we will be, I hope, good to go. Right, so thank you very much for inviting me to talk. Can I just check that everyone can see the slides?
Can indeed.
Excellent. Right. So, as has been mentioned, I'm the Vice Chair of the World Space Week Association, an organisation I've been involved with for a long time. But I'd also like to say I've been involved with SpaceUp for a long time. I helped crowdfund the very first one in the US. And I first met Remco at the famous SpaceUp EU in Ghent, and I just spotted myself in the crowd picture just then. So there's a lot of similarities, a lot of synergy between World Space Week and SpaceUp. So what is World Space Week then? Well, this goes back to 1999 when there was a United Nations conference, Unispace 3, being held in Vienna. And one of the things that came out of that particular intergovernmental conference was that the UN mandated World Space Week. There had been a number of Space Week celebrations in different parts of the world before then, but they came up with it, and this is the definition: to celebrate each year at the international level the contributions of space science and technology to the betterment of the human condition. And it runs from the 4th of October to the 10th of October each year, and these dates were chosen to commemorate, firstly, I think the more memorable date, the 4th of October, and the launch of Sputnik 1 in 1957. And unless you're a bit more of a kind of space geek, particularly in terms of treaties, the signing of the Outer Space Treaty in 1967, which was on the 10th of October, but that did at least give a nice bounding. And since that time, World Space Week has been promoted globally by the World Space Week Association. And if I can get the slide to advance. So there we go. World Space Week is therefore promoted as the largest annual public space event on Earth. Much like SpaceUp, anyone can organize a World Space Week event, and I'll come back to that later on. But the purpose is to try and attract global media attention by having lots and lots of events all at the same time. If you're in possession of a microgravity or zero gravity flight aircraft, you can do that. Here is a former president of the United States looking through a telescope. Here are some events in other parts of the world. This one may be more difficult to interpret. This is actually the then World Space Week logo. We've changed now to this simpler branding, being projected on the side of an inflatable space module in orbit. Pretty much anything goes. Why do we do World Space Week? Well, first of all, it educates people around the world about the benefits that they receive from space. I suspect that most of the people watching tonight don't need convincing of that, but some people need that, and this helps get the message out. It encourages greater use of space for sustainable economic development and demonstrates public support for space programs. And I think this picture in the bottom left, it's actually a school, but it's still quite impressive as a sort of public manifestation of interest in World Space Week. An entire school, in Bangladesh, processing down the road, holding a banner. But it doesn't have to be quite that formal. Here you can see, another event in Asia. This is, a slightly more party-themed event, but the point is it gets the message out there. Also, it excites children about learning about space and their future. And here you can see, two classrooms. One on the left where they have constructed a rather nice diorama of space, and one on the right where they're obviously having a high-stakes competition on questions about space. It also promotes institutions around the world that are involved in space. I've seen a lot of stuff on social media, particularly for World Space Week 2020. I think that's going to prove to be our best one yet, and it fosters international cooperation in space outreach and education. Each year there is a theme, and in 2020 the theme is Satellites Improve Life. You can see the rest of the themes there. I'm not going to read every single theme since 2000, but I would just like to flag the theme for next year, which has already been decided. The theme in 2021 will be Women in Space. So you've got a year's notice to start coming up with ideas for events to run in World Space Week in 2021. So how does it work? Well, I've already kind of touched on this. We synchronize many events. In the past, when we started, Facebook didn't really exist. Social media was new, but now obviously social media helps a great deal. These are 6 things I pulled off Twitter earlier today. One of them from the National Space Centre in Leicester. I thought that was relevant there. Bottom left, you can see NASA STEM engagement is promoting World Space Week. Individuals can do it. The one in the middle top, Alice Gorman, she's a lecturer in space archaeology in Australia, and today she's been posting a kind of what she called a Sputnik burger, and here you can see the olives, but replaced with cherries because they're more round, with 4 cocktail sticks in to make Sputnik garnishes, which I thought was very creative. At the bottom, the University of Greenwich in the UK, talking about their design project and referencing World Space Week. Top right, Viasat in Brazil, a South American communications company. And bottom right, the one actually I was most surprised by, the NATO Allied Rapid Reaction Corps. Okay, is apparently, I didn't know this till I searched on the hashtag, launching their space course during World Space Week. And so, I figure if the military are, promoting World Space Week, then we finally achieved, the sort of recognition we're looking for. Because this bar chart here shows you, the progression over recent years, 2012 to 2019. And I remember when World Space Week started out, people didn't automatically know. Now I think most people in the space community start thinking, oh yeah, October is coming around, we should start thinking about World Space Week. But I remember talking to space agencies, trying to convince them, to prepare, and having to remind them, year after year after year. But now I think it's finally getting there. I did have some strange conversations along the way. The director of international relations of an unnamed space agency said to me, so this is kind of run by the United Nations, is it? And, so there's a central plan, international plan. And he, I guess, coming from a very hierarchical organization, sort of viewed that there was a World Space Week authority that would tell the world how to organize World Space Week. I said, no, it's not like that. And I was trying to think of a concept he would understand. I said, it's like Space Christmas. Everybody knows it's Christmas, but there isn't an international Christmas authority, or substitute other celebration depending on on your culture and background, but the European one. So everybody knows it's Christmas, and so everybody celebrates it in their own way. So that's the way that it works. The World Space Week Association comes up with a theme. It has a certain amount of support for central activities, but then it's about getting a global network of volunteers. And I've mentioned in these bullet points who's involved. Obviously the UN Office for Outer Space Affairs in particular, obviously the World Space Week Association, but critically around the world there are 85 national liaisons, and what they do in each country is to organise events. In the UK, I should give a shout out to the British Interplanetary Society, of which I have been a member for 40-something years, longer than I want to recall, really. But anybody who wants to be involved in World Space Week, much like a SpaceUp, can do so. It's a grassroots activity. Here is a capture of the 2020 events map that I took earlier today. I think there's somewhat over 2,000 events currently on the map. We usually get a lot kind of added to the list actually after World Space Week, when people are starting to catch up with the paperwork. But you can see, it's got a very significant coverage in the Americas, in Europe, down through India, not so much in Africa and Asia. So there's still work to be done, but I expect some of those to fill in as time goes on. We have a wide range of global partners, and you can see the various partners here. I'm not going to read through all of them, but you can see a variety of international organizations, predominantly. I will also give a shout out to Yuri's Night in the bottom right then, because that's another similar kind of concept that happens in April each year, 6 months apart from World Space Week. And I also used to be a Yuri's Night organizer in the days when I lived in London. So those are the global partners. We also need some people who give us money from time to time for the central functions. And so here you can see here are our top level sponsors. SES, the satellite communications company, Lockheed Martin, aerospace company, Northrop Grumman, Thales Alenia, similar, United Launch Alliance, people who launch rockets and payloads into space, and Astrax. I don't know so much about Astrax, actually. I need to check up on them. But those are the sponsors and the donors, of which we're very grateful to have their cooperation and also their financial support in the case of the donors. So what can you do? Hold an event during World Space Week. Oh, what about a SpaceUp Live? Well, the two Ryans and Remco have already done that for this one, but maybe it's a little bit late to run your own World Space Week event this year, but you could certainly think of one for next year. These are some suggestions, but there are many other things. I'm doing some more online lectures for a couple of places in India, actually, tomorrow and on Friday. Got another invitation for one on Saturday. I think we'll have to see about whether I can fit that one in. But literally anything to do with space. Ideally, it fits with a theme, but it's not absolutely essential. What we really want is this upsurge of activity, from all the space enthusiasts and organizations in the world. And if you can't organize an event yourself, at least spread the word and encourage other people to do so. So thank you very much. That's the end. If there's any questions, I'll be happy to take them.
That's brilliant, Chris. If anyone wants to put questions, just put them in the chat on YouTube, and we'll pick them up.
So let's just see. So yeah, if we've got any questions, there is a small delay on YouTube, but
yeah, it's just showing my last slide there.
No, I don't know if there's any particular questions.
We're all busy making plans to
yeah, hopefully. Hopefully.
I mean, that's the goal.
That's the goal.
Well, I see that Pavlo's joined us, so unless there's any questions, maybe we head straight to Pavlo. So let's just let him in. So yeah, Pavlo from SpaceBit is our sponsor for this event. So he's just joining us now. And so let him connect. Hi, Pablo.
Yes, hello.
Are you hearing us? Yeah, you
Yes,
just
I
got
can
here
hear
in the nick
you
of
okay.
time.
Yeah, I'm here.
Yeah.
Yeah, so
Just over to you.
Yeah, I'll stop
yeah,
sharing so you
well,
can present if you
thank
want,
you
Pablo.
very much, Ryan. Yes. Well, as you know, we've been working on a lunar mission for quite some time, and yesterday
Your video on, sorry, Pablo, your video. Oh,
just 1 second. Yeah.
yeah. Okay. There you
So
go.
as you know, we've been working on a lunar mission for quite some time, and actually yesterday we made a new announcement that we are not only flying on a Astrobotic mission, but actually we are also flying on intuitive machine mission, and that's something very new. And I want to share with you a few slides just to demonstrate what is it all about and how it's possible to engage with our mission. So just sharing now. Yeah, sure. Can you see my screen? Yeah. Okay. So yes, we're flying to the moon 2021. We have a fully funded mission with Astrobotic. We are post CDR stage for the first mission. So now we're actively testing and finalizing the ICD and development of our rover. Everything is going fine. That's the rover, obviously, and it's due to be launched in August 2021. It's an international project already. We have few engineers in the UK, but also in the US and Poland. And the reason is because in a short period of time, we had to assemble a team of engineers and do it real quick. So first mission, ULA Astrobotic in August, and second one, which we just announced yesterday, is going to be intuitive machines sometime in autumn 2021, so launching with the SpaceX. And we are planning to have a wheeled rover for the second mission. So the reason why we decided to book with intuitive machines as well is that we want to ensure that we are definitely getting to the moon, and I believe that many people are waiting, and it's an important mission, so we have to make it work. That's why we have intuitive machines now as well. And it's a new rover design. Obviously, some of the internals will be the same, but as you can see, the actual design is very different. And first one was specifically designed to go into the lava tubes and explore inside of the lava tubes. That's why we had this interesting design with legs. But the second one is going to a different region on the moon, and we are planning to have wheels. I believe there are a few questions there. Okay. So basically, can you see me now?
Yeah, perfect. Yeah.
Okay. So for mission with the intuitive machines, we are looking for partners. When I say partners, we are looking for engineers, for companies who want to engage in a lunar mission. We are very open, so we want to make it as wide participation as possible. The reason for that is because at the moment we're building 2 robots, and it's a bit complicated, as you can imagine. So if you believe that you can be one of those engineers, it can be robotics, it can be software, and similar. We probably quite well in terms of thermal engineering and things like that, but in terms of the robotics, yes, please, you're welcome. It can be a company, so we would form a partnership with a company, or it can be an individual. So we open for all opportunities. Also, as we want to do science, we're really interested to partner with universities, give data of certain degree of granularity for free to universities in the UK and some universities internationally. So if you're interested, and you want your PhDs or even master's degree students to engage in the lunar mission, we can give you a list with what we have in terms of the equipment, in terms of the actually what kind of measurements we will be taking, and we can share this data as we progress with the mission. Basically, as I said, the first mission, it's quite historical, 50 years from the American soil, first rocket, which is actually going to the moon. First one for the UK, second one just in a couple of months after the first one. So in terms of the technical developing, it's all very challenging, and that's why we want to reach out if someone wants to engage with the mission too, which is basically almost the same time. You're more than welcome. In terms of the development cycle for those interested who is engineer, we have approximately 12 months because we have a bit more relaxed schedule. I believe that the manifests are closed from what I know for the both missions. So it's kind of a chance to participate in those missions if you wish. As you can see, we're also planning mission 3. We don't really know when it's going to happen. We would imagine it's Q4 2024, but that's kind of a question mark. And for the mission 3, our idea is that we want to launch a larger mission with the larger rover. We demoed that rover at the event in London last year. So if you were at that event, it was possible to see it. And this rover, basically what it does, it can go and it can nest, what we call this process nesting. So it can leave small rovers on the ground, and then basically it can drive to a more remote location. It can host up to 4 smaller robots from mission 1 and mission 2, and then we can do more science. We can do more exploration during that mission. If you have any questions, I would be glad to answer now. As you know, we are already quite international. I mean, we are UK business, but we also have offices open in US, Luxembourg, and Japan. So if you kind of have the questions or want to participate, you can write me, or you can write to generic spacebit email info@spacebit.com. Yeah, thank you very much.
Thank you very much, Pavlo. So I think we've quite a bit of time for some Q&A. So if anyone has any questions about SpaceBit and their plans, if you want to write it in the YouTube comments.
There's some already there, Ryan.
Yeah, I already see one there. So so Pavlo, how far do you expect to have to walk to find a lava tube? How long do you see this taking?
Sure. I mean, for the first mission, it's very challenging. So our expectations are limited for the first mission. So we don't, we are not 100% sure that we will be able to enter lava tube during the first mission. So that's the plan for the mission 3. The first mission is mission tech demo, basically walking more than 5-10 meters on the moon and demonstrating that you can do that, you can walk on the moon. And if we are lucky, there are lava tubes in the proximity of our landing site. And we are working with scientists from JAXA, from Japan, on identifying potential spots. But as you can imagine, we are a secondary payload. We are flying with astrobotics, so we are dependent on their landing site. And so it really depends where we land. So in terms of how far we can go at all, we are limited by Wi-Fi that we have on board, and Wi-Fi is up to 200 meters. In our case, 150 to 100 meters. So that's kind of our furthest goal, if you wish. But the minimum is 10 meters for mission.
Thank you, Pavlo. We've actually got another question from Nick Howells. How much have you modelled the surface regolith at depth for the Spider robot? And what's your mitigation for the adhesion and general nastiness of it?
Yes, very good question. Actually, if you're an expert in regolith, please reach out. We are looking for people with different experiences. I mean, during the first mission, the Soviet lander, the Korolev had to make a decision that it's not a few meters, it's that much of the regolith that you're gonna experience on the moon. And obviously in different spots, you can have different thickness of the regolith, and we're aware of that. So the region where we're flying, we would imagine we would have around 2-3 centimeters max. So our legs have special design. They kind of like a ski poles in a way. So you have a sharper end, and then you have sort of a more if it's deeper. We don't expect it to be deeper, so we expect to kind of reach the hard surface of the moon through the kind of a soft top part. But obviously, we are still in discussion in terms of what to expect. So if you have more kind of deeper knowledge, or you want to engage in a scientific discourse about that, definitely reach out to our team.
Brilliant, thank you. We've got one from Jeff now. How long will the rover last, and can it stay charged?
It's a good question. My first mission, the ultimate limitation is around 11 days, because we are descending on the second Earth day of the lunar day, and we will have quite some time till lunar night. But obviously, there are challenging environment. To the region where we're flying, the temperature is going to be around probably 80 degrees Celsius. So it's not 130, it's around 80 max. So it's not too bad. And obviously, we are not going through the lunar night anyway. So the maximum is around 11 days. But it also depends how we land. So if we're in the shadow at the beginning of our mission, it's more challenging to go into the light, because in the shadow, temperature drop really, really fast on the moon. So there are a few challenges and a few unknowns, but we can walk for a couple of hours on our charge, plus solar batteries, so we can potentially stay and recharge. But obviously, there are the limitations in terms of the motors, in respect to regolith and many others. So it can be from hours to a few days, but the maximum is 11 days.
Thank you very much, Pavlo. I think we've got time for a few more questions. Well, another one from Nick. Why are you using Wi-Fi and not, say, LoRaWAN, which would give you the lower data rate but much greater range up to orbit?
Yes, it's a very good question. It was not our choice. We have to use Wi-Fi because that's a requirement from Astrobotics. They don't want their payloads to go any further than that. We don't know the answer why. I can just imagine why. Maybe from the legal perspective in terms of the claiming something on the moon, or maybe something else. But I mean, Wi-Fi is interesting protocol, so it's relatively easy to connect. Should be working on the moon as well. And we don't have to talk to orbit. We have to talk to the lander, as you can imagine. And lander would relay our signal back to Earth. That's our plan at the moment. And basically, our data stream is not so much limited with the lander, but it's limited with Earth. So we have a very small data channel from the lander to Earth. So that's the largest problem. It's like a bottleneck for us.
Brilliant, thank you. I think we've got time for maybe one more question, and it's another one from Nick. What's your plan for radiation mitigation with respect to the OBC?
Well, actually, radiation is not that bad in terms of our calculations, because I mean, if you look even at the low orbit or CubeSats, and the times that they expose to radiation, it's much longer. Our mission in transit is around 3 weeks, more or less, and then the moon. So our radiation exposure is really limited, even if you take into account the higher dose of radiation that you can get on the moon or in transit. It's it's still kind of not that high. Our largest concern is is thermal protection. So thermal protection is much bigger concern because the envelope that we are flying in is limited by mass. As you can imagine, it's 1.2 million. So we had to design something very, very tiny, less than 2 kilograms. And basically, our envelope gives thermal protection. And we believe with heaters, we're going to make it through the transit. So transit is more challenging because we just basically offline using heaters and using shielding. And I don't see that radiation is going to be that much of a concern. Obviously, if you want to work on this matter, please contact us and we will discuss it in more detail.
Brilliant. Thank you very much, Pablo. That was a really interesting presentation and some great questions as well. I think Nick's in the comments, so I'm sure people will be discussing this talk for a little bit. Nick says we need to talk, by the way, Pablo, so I'm sure you two will be in contact. So let me just share my screen real quick. Okay, so next up, we've got the grid sessions. And as I said before, they're 15 minutes for the presenter to do whatever they want. Normally, it's 10 to 30 minutes, followed by a few questions and answers. If you've got questions throughout the talk, do put them in the YouTube chat. They will catch them at the end of the talk, because obviously there's a bit of a delay between us streaming and you guys seeing what we're talking about on YouTube. So the first talk is by Shamiska from the University of Leicester, who's going to talk about space for equality and inclusion. Then after that, we've got Ashta from the University of Leeds Business School, who's going to be talking about exploring methods to improve the gender balance in SpaceUp Leicester and SpaceUp Live events. So we're really excited to see this one actually from a personal perspective. I've been working with her on this for the past good few months now, so I'll be excited to see the results. And lastly, we've got Barath, who's a student, and they're going to be talking about space for everyone. What does it mean, and how do we get to space being for everyone? So without further ado, hand over to Shamiska if you want to start sharing your screen.
Hi, yes, can everyone hear me?
We can indeed.
Hi, yes, so I'm Junaid, I'll be presenting. Hi, yes. So I'll be presenting alongside Samiksha. I'm just going to share my screen now, if that's okay. Okay, so screen one. Right, present. Okay, Sam, if you want to kick it off.
Yeah, sure. Hello, everyone. First of all, happy World Space Week. Today, me and my colleague are going to talk to you about something that we found was quite fascinating. So here we go.
Okay, so quick kind of section on presentation etiquette before we move on. So obviously we're talking quite a relaxed manner. It's a formal or probably informal presentation, and we really don't want to put you guys to sleep. We'll have time for questions and answers at the end. And of course, because of the nature of this, we're open to criticism and debate and definitely encourage discussion between you guys and us. And finally, if you guys are interested in getting sent a copy of the paper, please send an email and we'll reference that below as well. So yes.
So who are we? I'm Sam, and June is my colleague who is studying computing with a keen interest in space science.
So I'm Junaid, and Sam is studying aerospace engineering at the University of Leicester. She's always had a keen passion for space, and we met through the New York Academy of Sciences, and that's why we kind of got interested in kind of pursuing research in space.
So most of us have heard or asked this question, do aliens really exist? But I think that we're really asking the wrong question here. I think we should be asking instead, what do we do if aliens do exist? And further, maybe see where that leads to. And if we do come in contact with them, how do we go forward with that? How do we communicate with them?
Yes, so this is essentially the core concept of the paper we wrote, which was on alien linguistics and how we might go about analyzing alien language in the short term. You know, how can we establish communications with them? How could we carry out a risk assessment and really understand their intentions and the kind of nature of their intentions on Earth?
So obviously there will be a couple of possible scenarios that we will encounter when we do come in contact with aliens. The first more likely scenario is aliens visiting us. And the second possibility is that we discover aliens and have no choice but to communicate with them because we have been seen and discovered. The third scenario is a bit unlikely, but more likely in terms of discovery, but unlikely in terms of having communication with them. And they are microbial life forms.
Yeah, so in this case, as Sam mentioned, we're really only covering the first two. So what do we do in a situation where we encounter extraterrestrial life and we have no choice but to talk to them? We need, you know, a really rapid way of getting to know them and really understanding why they're here and what's going on. So the first things first, it's this concept of responding rapidly to the encounter. So the overall aim of this is to complete a risk assessment to ensure, first of all, no harm is done to or is imminent to any parties, but also to get an initial understanding of the situation, you know, understanding the nature of them, so their biology, understanding, you know, their intentions mainly as well. So again, so we've got a simple kind of input-output going on. So what we want to do as humans is some kind of short-term evaluation, some kind of risk assessment, ultimately to ensure safety, no harm to any parties, and a mutual understanding, which is the #1 priority here as well. Now, there are a range of factors that affect this rapid response. So one of the biggest ones that people tend to overlook is physiology. So the fundamental kind of starting point for humans is our physiology. So if, for example, we have our lefts and rights, that's determined by our limbs. You know, we have 2 arms. The fact that we can see and hear and we have these 5 senses really shapes the world around us. So we really have to ask, you know, first of all, what do the aliens feel? How do they talk? Because of course we can't be communicating with them, for example, with electromagnetic waves, but the aliens, you know, are communicating with us through something like sound. So it's really important to establish the initial medium as to how you're going to talk to aliens.
So moving on to the, sorry, if you want to.
No, go ahead.
So I was just starting to get into the factors that will affect the way in which we choose to establish a mode of communication. And the main reason in doing so is to basically ensure safety of our human population. So obviously, before we can jump into that, we need to know what kind of mode that we need to take in to establish communication for safety. So obviously, as my colleague said, the physiology really does matter a lot by knowing if they can hear us, if they can see us, or if they can sense things. We can use these factors to sort of say, hello, please don't hurt us, and we're not going to hurt you, and take it from there. And they could be also very advanced and might have technological implants within them. And hence we might have to use a completely different kind of technology to just communicate with them. And of course, there's a much rarer case where they're completely up there and they have superpowers such as telepathy to communicate with us. So these are some of the factors affecting that.
So all of this might actually sound pretty crazy to you guys. You know, you might ask, what's the real chance of us encountering this extraterrestrial life? But as we said, it's not about asking, you know, whether we will encounter them. It's more so saying, what will we do if we encounter them? Because this is one of those problems where once it happens, you're in the moment and you need a solution immediately. And so this is kind of what we're focusing on. So the next thing that we wanted to talk about was this concept of gathering information just within your initial risk assessment. And there's a range of factors that you've got to understand and get information on, basically, before you proceed. So this can be done through simple concept of gathering intelligence. It's usually a military concept, but it extends elsewhere. And that's just the concept of gathering information, analyzing it, evaluating it, and then distributing it, whether that's among nation states or other interested parties. So what are these factors that we need to understand? Well, the first thing is human safety and security. So that involves threats. That involves, threats to humans directly from the ET life. It might involve, global riots causing hunger. Really trying to understand what are the effects on humans, both from a perspective on Earth, but also externally. So how the ET life affected. We also need to know the intentions of ET life. And this one was quite an interesting one when we researched it, because initially you want to know, are you hostile or not? But then there are secondary considerations, are they here for tourism? Are they here, to completely obliterate everyone and take our planet? Are they here for, a really specific purpose? And that's something that needs to be established as well if we're going to start to get an understanding of what's happening. There's also the element of negotiations and the nature of dialogue. So that's coming back to what we mentioned before as to how we're going to talk to them. So how do we go about doing this initial negotiation, this initial information exchange? And offensive capability and extent of awareness. That's really just talking about, what are the initial signs from the aliens? Are they showing any kind of weapons? Are they showing signs of peace? What kind of situation are we dealing with? What do they want to show us? And what can we read from that? And finally, there's selecting an engagement party. So, who's going to go out and meet them? Are we going to have anyone going out there and meeting them? Is this party going to be a team of scientists? Is it going to be military? Which countries are going to come from? All these kinds of things have to be determined on the day. And there's also managing the announcement of ET life to the population. So if it hasn't been known already, how do we handle the security threats that might arise from basically telling everyone on the planet, hey, look, there's extraterrestrial life. From a linguistics perspective as well, there's a few important things that we need to know when forming the plan. And we'll go over this quite quickly because we're running out of time. But so these are essentially a bunch of principles that we came up with after doing research. So the first one we came up with was that sentiment analysis is really important. Now, what is sentiment analysis? To summarize, it's basically you trying to understand someone's sentiment. So are they feeling good about you? Are they feeling bad? What are their opinions? So the core process to make an effective assessment of alien risk is really to understand, are they, what do they think about us? Are they even insulted by us? Are they fascinated by us? Those kinds of things will allow us to start talking to them. The other thing is we found that grammatical rules and language syntax is quite irrelevant to understanding the nature of language. So for example, when humans talk to each other, we use body language, we cry and laugh. Even if people, get their syntax wrong, we talk to people who don't speak our language, we can still understand them. So generally, we shouldn't put much effort into that. And there's also distinguishing between semantics and pragmatics. So in language, semantics is essentially the meaning of a sentence, but pragmatics is the meaning in context. So if aliens make, a statement, do we consider context? Do we take them literally? That kind of thing as well. So you've got to be really careful in how you interpret that. And finally, there's the existence of morphemes and phonemes. So these are just units of language. So the aliens may have their own language. What's the smallest unit of sounds that the alien can make that will convey a difference? So for example, if I use the word jump, that indicates jumping in the present tense. But if I say jumped, that extra ed at the end can be a morpheme that suggests past tense. So really understanding the little things in their language that change meaning of words. And finally as well, physiology. So as we mentioned before, being aware of alien physiology to determine how they might perceive the world.
So in order to go further in determining which way to continue to communicate with them and to know how we can learn their intentions and further see what we can learn from them, we have to first know what their intelligence level is. This will allow us to further communicate with them and connect with them on different levels. So obviously there are three main levels that we came up with, as you can see on the screen. We sort of wanted to give a reference point so we can understand their level of intelligence, comparing it to our level of intelligence. So we started off by that point of perspective. So human-like intelligence is the kind of creature that we will sort of be easily able to connect with and understand and possibly develop a mode of communication. Then we have either two sides, low intelligence and very high godlike intelligence. This will allow us to carry on with what we want to do and what they want to do and sort of negotiate into peaceful means.
It's also quite important to consider as well, this identification of intelligence really only applies to if we discover aliens accidentally and they've seen us as well, and now we have to talk to them. Because of course, so we hypothesize again, if aliens manage to land on this planet or they manage to come out and talk to us, they probably are of a much higher intelligence. So that's like a general kind of reference point to start off with. So then we start off with the long-term evaluation. So we've done this really rapid risk assessment. What if the aliens want to talk to us over the long term? What do we do here?
Before we get into that part exactly, you probably want to know, why should we do this? Here are some of the reasons why we should communicate with them. They might have solutions to some of the major problems that we face here on Earth, and some of these issues are related to climate change, natural disasters, diseases. Aliens might have already solved them and completely eradicated them on their planets, and we might be able to gain from their knowledge and intelligence to do the same here as well. They might have advanced technology that we could benefit from for various reasons. On a more fun level, they might have solved how to travel at the speed of light. And this is definitely helpful for us, because if we want to become a galactic species, we would obviously need to travel in that radius. So they might have the solution to that as well. And lastly, a more philosophical perspective, they might know the answers about the universe and its very creation that we ourselves are not able to answer. So it will be very interesting to hear and learn what they have learned from their period of existence, and how we can use that information to further become more evolved as humans.
Cool. So I'm a bit conscious of time, so I'll rush through this last part. So this element of long-term evaluation, as we mentioned, it's really, really important. So we need a deeper picture of some kind of mutual language. We need to understand the behavior if we're ever going to kind of integrate with them. And we found probably the best way to do this is actually using quite a new field called computational sociolinguistics, which is a field where we can use computers, artificial intelligence, and things like big data technology to analyze aliens, the way they work, the way they behave, and especially how linguistics influences that. So there's lots of things that we can study. We know, again, in our society that gender can influence language, age can influence language. We found that, for example, older people tend to talk in a more standard way. So we could measure the disparity between the way aliens talk as a way to measure their age. We could study, how linguistics affects changing social relationships, style shifting, which is essentially, if I'm talking to a boss, I'm going to be talking really respectfully, whereas my friend, I'm going to be talking informally. So all these things we can really kind of start to analyze to give a huge picture of aliens. And a lot of people overlook that we can actually study language to do this.
So ultimately, what are we aiming for here? Definitely awareness needs to be raised on the topic. There's not much research out there about alien linguistics, as we've mentioned, and we're very excited to sort of expand on our research and hoping to gain feedback from the audience, and definitely questions and criticism. So this topic itself can be widely known and further researched on, because it definitely seems like there's a need for more research in this field, as it is a very risky one, as in, what if aliens were to visit us and they might do some serious damage to us? So we need to prevent that, and hence we need to spread awareness about the topic and research it more.
Okay, thank you very much for listening, guys. If you guys want any more information about this, or you want the research paper, there is an email that you can contact us on as well. So yes.
And that's etlinguisticsauthors@gmail.com.
Thank you very much, guys.
Yeah, fantastic talk.
Thank you.
Yeah, I'm just conscious of time now, so
Yes, we did overrun a bit. Apologies.
Yeah. So I think if there are any questions, if you can put them in the chat, we do need to move on, I think, to the next topic. But if either of the speakers want to reply in the chat, then
there
they
was an
can.
interesting discussion in the chat, Ryan, so it's worth looking at.
Let me see. So OAI.
I mean, not for now, but for them, there's interesting stuff. So let them have a look at it. We'll move to the next speaker.
Yeah.
Okay.
So the next
Brilliant.
speaker
Thanks again,
is
both of you. So yeah, as Ryan was saying, thank you very much both. The next speaker we've got is Ashta from the University of Leeds Business School. So Ashta, are you ready?
Absolutely, thank you so much. So I'm just gonna try and share my screen now. There you go. Hi everybody. Well, that was an extremely interesting presentation to follow. So I'm Asta, and I'm an analytics and marketing student from the University of Leeds. And a few months ago, I collaborated with R&R Space to conduct a research in attempting to propose strategic marketing and communication suggestions for SpaceUp Live and SpaceUp Leicester to help them achieve a 50-50 gender balance in their participants from a current split of 79% males and 51% females. And today I'm going to be presenting a very brief summary of the research that I conducted. So with increasing awareness about gender inequality or equality, if you say, event organizers are becoming more aware and are compelled to acknowledge and ethically address gender issues related to equality and diversity. And that's how R&R Space took the initiative to take a step or make an attempt towards it. So now from a marketing perspective, gender is an important determiner in formulating marketing strategies. It's also a very important attribute in determining and predicting the intent to purchase, which in this case translates to the intent to participate. So as a result, since the focus of the study were women, the question I tried to address through my research was what could be the most effective communication strategies to increase participation intent among women for SpaceUp Leicester and SpaceUp Live. And resulting from this, my goal was to propose strategic suggestions to increase diversity amongst the participants from these events that was stemming from my empirical results of the research. So to achieve this, my first step was a secondary research strategy. And that included assessing all the existing information that I could gain from the current marketing and advertising strategies on all their platforms, recording them, and checking the current database of previous attendees to see all the splits or any patterns, and assess the current flyers and leaflets, emails, invitations, and try to assess them parallel to previous empirical research available in this field to back up my research process with some theoretical evidence. And so the kind of streams I looked into was the importance of gender segmentation in any sort of marketing or communication strategy, and information processing styles for men and women separately, and the exposure an ad would need in helping them understand and comprehend these ads. Also, influence of ad elements, which include inclusion of speakers or other components, design, aesthetics, and lastly, general gender differences in event attendance in all types of events. So, well, Okay, well, that went by quickly. I'm sorry. Right. So as a result of all this research, what I tried to do was find possible factors that could influence the attitude towards ads. And I found 7 factors and tried to include them in a framework. And I found that there were 5 factors that could affect the attitude towards ads. So women could have a positive attitude towards ad if they have a positive impression or opinion of the relevance and completeness of information in ad, the possibility of ease of search options and the variety of search options available to them in the ads, how easy the language is to understand, and how simple and informally is it presented to them, and the visual appeal of the ads, the aesthetics, as well as the event image they create based on the ads. And in turn, having a favorable attitude towards those ads could translate into a favorable attitude towards the event, which would increase their intention to participate in the events. And I also included other factors like the design components, which includes layout, color schemes, as well as ad elements that usually other ads would include in their strategies, the willingness to pay for an event like SpaceUp Leicester, and other compelling factors for people to attend an event, for instance, the opportunity to network, the variety, and the diversity of speakers. And to achieve this, I mainly proposed 2 methods. One was to do interviews of previous female attendees, speakers, and panelists of SpaceUp Live in Leicester to get a detailed insight into their experience of the event and their feedback and suggestions for the same, as well as a qualitative analysis of a survey I conducted with female participants who were given a visual stimuli of the current advertising material of SpaceUp Leicester and SpaceUp Live to find out what are the possible factors that are influencing their participation intent. Now, based on all these methods and analysis, secondary and primary, I could summarize some of my results here and what implication it could have for R&R Space in improving. So it turned out that language being easy to understand and clearly presented, as well as informal and non-expert, turned out to have a positive attitude towards the ad. In addition to a better visual appeal of the ad would also determine a positive attitude towards it. And there was a higher possibility of women attending an event if they had a positive impression of its advertisements, which only goes on to tell us how important these marketing initiatives can be in ensuring that they're willing to attend an event like that. And it turns out that the positives of their current initiatives and marketing material is the usage of images and logos, the font colors, the color scheme in their ads. And it's working great for them, which is rather pushing people to attend the events. However, there is scope for improvement in the layout, in making information more clear, distinguished, and less into information blocks. And there were suggestions of improving the typography to keep in line with the theme of the ads and marketing material. So having a constant thematic aesthetic approach in the ads towards all the platforms, all the methods, all the channels would rather increase the chances of them having a positive attitude towards it. In addition to including more relevant images of perhaps the previous attendees or previous SpaceUp events in the current advertising, so people get a more visual appeal of how these events are and how they're conducted. The positives about the language was that it came across very neutral, which is a good thing since it didn't lean towards seeming one way or the other. A usage of terms like space for everyone turned out to be extremely encouraging for people to want to attend these events. However, a point of improvement was the language could seem less technical or non-expert to appeal to a wider demographic, since the target of SpaceUp is to include anyone and everyone who's interested in space. And even though it's neutral, there could be efforts, especially on social media, to deliberately and making the language sound more inclusive and more apparent. Also, one of the major reasons for people to attend the event, and that's working the most positively for the event, is the networking opportunities that it provides, as well as the variety of speakers that always show up in all the events, which is very encouraging for people. However, there could be additional things that could be done to support such these options, which is having a constant credible spokesperson or endorser to have a relatable or aspirational value to a larger demographic who would perhaps be able to relate to people who are not only just in space professions. Also providing more information, not only about the concept of the event, but the opportunities it offers, and even logistical information for SpaceUp Leicester. There were a lot of promotions about or promoting it to specific women networks, or rather even starting at grassroots level by advertising it to women and girls in schools, and specific networks for women in STEM and women in other fields, and advertising it pan institutions and not only specific departments related to science or space. Also, frequent reminders on social media was also one of the important suggestions that was proposed, because getting more and more information and reinforcing the presence of the event would result into a more positive attitude towards its attendance. And lastly, there was proposition of making some basic logistical and practical improvements, which would include having online coaching sessions or methods to prep the participants for the speaking and presentation opportunities that they might encounter during the event, so that women or other underrepresented sections could feel more prepared and confident to take up those opportunities. While the results show that there was willingness to pay for the event, the bracket in which they were inclined to pay was between £10 to £20. So it's obviously a consideration to check feasibility of price reduction. Well, we know how that works out, but it was just reflected in the results. Other logistical improvements could have been travel support and bursaries for the SpaceUp Leicester event, ticket price concessions for a few people, or rather students, which could be supported by the sponsors, customization for t-shirts for women in terms of really small initiatives like making them more comfortable or different for them, and ensuring there's documentation of all the event activities that goes on. So the contribution made by women and all the diverse communities is recognized, and they feel this way because such small initiatives seem to actually make a big difference. So, however, a large sample and more research can bring out more and more factors that could influence this and perhaps give different results altogether. So this will always be an area of speculation, and R&R Space are trying and willing to make these changes to gradually figure out what works best in terms of inclusivity for the events. And I'm certain that this continued effort is what will result into letting them present this plethora of opportunities that the event offers to a more inclusive and diverse community. And well, I guess that's the aim that they have, and that's the aim I've been trying to help them achieve. So yeah, I guess, thank you.
That's brilliant. Thank you very much, Asha, and some great suggestions there. We'll definitely be taking them all on board with events going forward as well. So I guess we've got time for one or two very quick questions, if there are any in the chat. But I've been looking through it. There's already some positive comments on the talk. So well done, and thank you again. So well, let me just share my screen. So I've got the upcoming talk coming up whilst we just wait for any questions to pop up real quick. Okay, so there's no question at the moment, but Ashley, would you be all right jumping in the YouTube chat and answering any questions as they come, if they pop up in the chat?
No problem.
Fantastic. Thanks again. Okay, so next up we've got Bharath, who's going to talk about asteroid definition, impact and prevention. Are you ready there, Bharath?
Yes, sir.
Okay, all right. If I stop sharing, yeah. So you can share now.
Okay. Is it visible, sir?
Yep, we can see it.
So I taken my topic as asteroid definition, impact and its prevention. It's a huge impact coming in the future generations. First, we talk about the introduction and its history. First, its introduction is asteroids are small rocky objects that revolve around the sun, and they contain most of the precious elements like platinum, gold, diamond, nickel, iron, etc. This in Earth, the researchers said the gold is come mostly from the asteroid only. Several thousands of asteroids have been discovered nowadays. History is the first asteroid is discovered by Gypsy PSA in the 1,000-kilometer asteroid in the main asteroid belt between Mars and Jupiter. It is named as Sirius. It is discovered in 1801. Later, in 1801 and 1808, 3 asteroids are discovered: Pallas, Juno, Vesta. We are in the next slide. We see the upcoming pictures. In 1845, Astra, 5th asteroid. These are the 5 asteroids discovered in the first 5 asteroids. First 5 asteroid pictures we see there: Sirius, Pallas, Juno, Vesta, Astraea. It's years are given in the ladder. The recent discovery is Sirius consists of the water molecules in it. You see a hole in that picture in the Sirius 1801. There is a hole in there. It consists of ice crystals present in it. Later, we see the classification of asteroids. There are 3 classifications of asteroids based on composition, based on orbit, based on the position of the asteroid. Based on composition, it is classified into 3 types: C-type, S-type, M-type. The C-type asteroid consists of clay and silicate rocks. These asteroids are 3.5 AU away from the sun. These asteroids are present in the main asteroid belt. Most of the asteroids consist of C-type only. S-type asteroids are silicate asteroids, and it consists of most of the silicate minerals and minimum of iron and nickel minerals. Example of this S-type asteroids are Juno, Eunomia. M-type asteroids. M-type asteroids, they are metallic asteroids. They are present in the outer solar system and the Kuiper belt. These asteroids are example Calliope, Lutetia. Later we see the based on position on the solar system. Based on position, it is classified into 3 types: main asteroid belt, trojans, and near Earth asteroids. Main asteroid belt, it is the asteroid belt between the Mars and Jupiter. This asteroid belt consists of millions of larger asteroids and millions and billions of smaller asteroids present in it. This asteroid belt consists most of the C-type asteroids only. The largest asteroid series is present in this asteroid belt. Later, in this picture, you see that violet color is the asteroid belt between Mars and Jupiter. There are millions of asteroids present in it. Later, we see the Trojans asteroid. Trojans asteroid are the asteroids that orbit along with the planet's orbit. In this picture, you can see that yellow color in the Jupiter's orbit. That are the Trojans of the Jupiter. They are present mostly in the L4 and the L5 points of the planet. L4, everybody know Lagrangian points. That Jupiter Trojans, there are most significant populations. recently NASA discovered the Earth ozone in 2017. Here we can see that in the picture you can see the green color circle. That is the Earth ozone. It is named as 2010 TK7. It is a 300-meter diameter asteroid that is present in the L4 Lagrangian point. There is no asteroid present in the L5 Lagrangian points. NASA is searching for it. It is discovered by Neowise. It is discovered in 2017 only. Later, the second classification is third classification, near-Earth asteroids. Near-Earth asteroids are the asteroids that cross the Earth. They are also called as Earth crossers. As of June 19, 2019, there are 10,000 near-Earth asteroids that are potentially hazardous that cause impact on the Earth. That cause entered into the Earth and they burn in the atmosphere. Here you can see the near-Earth asteroids. That blue color dots here, you can see that are the near-Earth asteroids, and the orange color are the asteroid belt, main asteroid belt between Mars and Jupiter. Based on orbital path, this is classified into 4 types: Apollo asteroids, R&R asteroid, Aten asteroid, Atira asteroid. Apollo asteroids are the asteroids that cross the Earth orbit, and its semi-major axis is larger than the Earth's semi-major axis, and its perihelion distance is smaller than the Earth's perihelion distance. Example of the asteroids is Bennu, Rogue, Didymos. R&R asteroids are the asteroids that are classified into many types that are they didn't cross the Earth orbit. They cross only the Mars orbit. They enter into the Mars orbit and didn't enter into the Earth orbit. There are the examples of Eros, Ganymede. There are 7,437 R&R asteroids. Aten asteroids are the asteroids that cross the Earth orbit, but their perihelion distance is the same as the Earth perihelion distance, and the aphelion distance is more than that of the Earth perihelion distance. So its example is Apophis. Atira asteroids. Atira asteroids are the asteroids that didn't cross the Earth orbit, but it encloses inside the Earth's orbit. Its perihelion distance and aphelion distance are enclosed within the Earth orbit. Its example is 2020 AV2. Atira asteroids are the not different classification, but it come under the Aten asteroids. But they are considered this as a different asteroid class. Atira asteroid consists of 18 different types of asteroids in it. Asteroid exploration. For asteroid exploration, there are different spacecraft sent by different agencies to take a sample, and the upcoming missions are for the asteroid exploration only. NASA, Japan sent Hayabusa 2 for sample collection. The upcoming slide we can see the detailed description of the two OSIRIS-REx and Hayabusa 2. The NASA Neowise spacecraft are orbiting the Earth, and it takes the continuous picture of the near-Earth objects and upcoming impact coming. These are the upcoming NASA missions to asteroids for sample collection and orbitals and the flyby mission. Lucy mission is to fly by the Trojan asteroids, Jupiter Trojan asteroids for flyby in 2021. Psyche mission is the asteroid with a quintillion dollar asteroid. It consists of most of diamonds, platinums, and the precious metals it consists of. Psyche mission is the orbital mission to the Psyche to 2022. Hera is a mission into double asteroid. It consists of asteroid and its moon. The asteroid name is Dimorphos and its moon is Didymos. For follow-up, and it determines whether it causes the impact on Earth or not. First, OSIRIS-REx Bennu. It is the asteroid mission. Its sample return is complete. It is returning to Earth now. It's launched in September 8, 2016 and reached Bennu in 2018. It's returned to Earth in 2022. It is planned to return on Australia. Its target is Bennu. Mission it takes a sample of 59.5 grams with this robotic arm. Its cost of the mission is 800 million. Hayabusa 2. It is a Japan mission to take the sample from the right asteroid. It is launched in 2014 and it is planned to reach Bennu in coming December 2020. and its taking sample is underground. Its duration is 5 years, but it going maximum than 5 years, and this operator is JAXA, and the cost of this mission is $149 million. Previous asteroid impact events, I detailedly put three only. So first, 65 million years ago, there is a dinosaur extinction. The scientists determined that the dinosaur extinction is mainly due to the asteroid impact only. 10 kilometer asteroid strike the Eurasian Peninsula. That causes the global firestorm and the cold snap, and finally it causes a global warming to cause the dinosaur extinction. In 1908, it is an iron asteroid. It causes an impact on the Tunguska, Siberia. This is a 50-meter asteroid and causes the whole forest to destroy and destroy the reindeers too. Safely, this doesn't cause any effect on the people because it damages in the forest only. So it that doesn't damage any people. Into 15th February 2013, it is not an asteroid, it is a meteor. It is a meteor named meteor. It is a flyby and a blast in the Russian Chernobyl Ural mountain region and causes the maximum shock wave, and it destroys the whole city's windows and damages the city. Characteristics of asteroid: the asteroids have maximum orbit around the sun. They must be smaller than the 10 centimeter. It may be outside or inside the solar system. It must be revolve around the sun, and it may impact or not impact with any planets or any others. How to protect the asteroid impact from Earth? These are the upcoming missions going to do with the asteroids. First, nuclear explosive device, kinetic impact, asteroid gravity tractor, ion beam shaper, focus solar energy, asteroid laser ablation. Nuclear explosive device. First, in nuclear explosive device, we determine the asteroid, and there are many missiles in all over the country. For example, cruise missiles, ballistic missiles that are present all over the country. These missiles cause maximum. These missiles are launched along with the rocket and released and they get impact with the asteroid and causes the asteroid to vaporize and deflect the asteroid from its path to a non-threatening orbit. The detonation and the proper use of propellant depends on the height, size, and the shape of the asteroid. Here you can see the nuclear missile attacking the asteroid in the particular way. Kinetic impact. This is the most advanced way using an upcoming mission in 2022. NASA is launching a mission to double asteroid DART mission. It causes a kinetic impact on the asteroid and test the asteroid. Is it possible or not? This mission uses a spacecraft and targeted near Earth object and gives and blast with the asteroid. Spacecraft and asteroid blast and causes a thrust to move away from the orbit. This is the kinetic impact. In this image, you can see the spacecraft directly impact with the asteroid. Like this impact, it doesn't cause any improvement when we attack when we impact with the side direction. It causes the impact. And moves the asteroid into the non-returning orbit. DART mission. This is a DART mission, double asteroid redirection test. This test is operated by NASA, and mission is asteroid impactor. It is launched in 2021. It is the test for the upcoming. It is NASA tested it in 2028. There is asteroid named 1997 AV2. It causes a maximum impact on the. It causes an impact with the Earth. Is it possible or not? It's based on NASA details. Impact date in 2020. Launch mass 500 kilogram. It pushes the Didymos moon away from the orbit and moves the moon away from the asteroid. anti-gravity tracker. It is proposed by Edward T. Lowe and Stanley G. Lowe. It is use of spacecraft and gravitationally pull the asteroid into a non-threatening orbit. Use of ion thrusters and we push the asteroid into a non-threatening orbit. It is possible only in the deep space only. It is anti-gravity tracker. The asteroid moving in the straight path due to the gravity tracker, and spacecraft moves the asteroid away from that path and moves the asteroid into a different path. And it is the same like a gravity tractor, but use of the light spacecraft. These are the light spacecraft give a thrust to and move the asteroid. It is proposed by C. Bombardier and J. Palliser. Forced solar energy. The forced solar energy is a good technique, and it is use of the concave mirrors and focus maximum solar energy and target the asteroid and force the solar energy into that.
Hi, sorry, time's up. You've had 15 minutes.
Okay.
Yeah, so a very interesting presentation, but we do want to get on to the T-5s and the panel as well. If you can continue chatting in the YouTube comments, I'm sure people have got some questions about that, or you can drop your place to get hold of the slides in the YouTube chat as well, and I'm sure people will be interested in that. But thank you very much for that. That was very interesting. So thanks again for our three grid speakers, and now I'll hand over to Ryan, who will introduce our T-5 talks.
Yeah, just give me one moment. And so yeah, next up we have Anita Burney from KISP Space. I hope I pronounced that correctly. KISP Space. Let me just put this in presentation mode. Anita, are you there?
Yep, hello? I'm here. Can you see me as well, or am I just talking to the slides?
We can see you.
Okay, cool. Let me know when you start the clock.
Yeah, there you go.
Well, hi everyone. I'm Anita Burney from KISP Space. Thanks for inviting me to, we skipped the first one. So I'm from KISP Space. We're all about making space more affordable and accessible for all. I'm also a member of the board of directors at AAC Clyde Space, and I provide advice on space matters to our Air Force as well. And I love all things space. What's open source? It's all about making designs available so that anyone can study and modify, distribute, make and sell the design, hardware or software based on those designs. And the open source satellite program aims to be part of that whole philosophy, a philosophy that is all about developing innovation and disruption in space, both in the spacecraft hardware and software, the in-orbit systems and the terrestrial elements as well, and figuring out how you can make open source part of that disruption. Open source started in the software industry, and that was really the start of the open source movement. Linux and MySQL, they were started decades ago, and they're really at the heart of a lot of systems and devices that we use every day today. And then we moved from disruption in the software industry to the hardware industry and the growth of the maker movement over the subsequent decades. You have firms like Arduino and Raspberry Pi and Adafruit and SparkFun Electronics, making electronics more accessible and useful for everyone else. Having worked at Surrey and supporting Clyde Space, I had to put some pictures in here of developments of small sats and CubeSats disrupting the space industry from the 1980s all the way through to the 2020s, really disrupting the traditional space industry and trying to do things differently. And then people started to think, okay, what cool things can we fly in space? And so we have examples of Arduinos and GoPros, Raspberry Pis and our regular smartphones from our pockets, all being flown in space over the past few years. And that was the genesis for open source space. So open source and space have been converging to create an open source space ecosystem. Here's a snapshot of some of the companies and teams that are involved in open source space. There's an open source satellite up in the corner that's working on microsatellite systems, spacecraft and missions alongside everything else. And it's really the perfect time for open source space right now, because typically space is too expensive, programs take too long to implement. It's difficult to make money back before the spacecraft end of life, and it's generally quite difficult for regular people to access capabilities. When you look at it from a business case perspective, it doesn't matter whether you're selling lemonade or selling satellites, it's all about cost or time. Cost and time to be ready to sell your product, cost and time to break even, and the cost and time it takes to actually make a return, because you want to do more than just, cover your costs. And that led us to identify the gap in the market. CubeSats and small satellites and traditional spacecraft, they follow pretty much a pretty steady curve of price performance, and there's really a need for a small satellite at CubeSat price. So we're developing the next generation microsatellite platform, the NGMP, to address that price performance problem. It's a design that's equipped for the 21st century mission needs. It's a clean sheet design. It's all about revolution, not evolution. And so we initiated the open source satellite program to make that design readily available for all, and also to develop an open source community that can use those designs and contribute to the overall program to solve the accessibility issues. How does the open source satellite program work? Contact me for our manifesto. It's a great paper. I'd be happy to share it with everybody. What we're doing is developing an ecosystem of participants, and that's sponsors, supporters, contributors, and collaborators, all working together. And alongside that, we're creating and sharing content with our community so that we can learn and share and work together what open source means in the space domain. And we're developing a repository, and we have some video content as well that you can access if you go onto our website. And what are we going to share? We're going to share everything. That's the whole point of open source. Everything from the design drawings through to the board layouts, assembly information, software source code, parts lists and schematics, so that you can take the design and try to build a spacecraft yourself. And we talked about building the community. Join us on our LinkedIn channel, and you can access our call for collaboration. We've already got collaborators working in our software projects and on the systems engineering side, and we're holding regular meetups. It'd be great to invite you along to join us. So if you want to get involved, do register on our website so that you can be part of the open source space movement. My contact details are there, and contact me on LinkedIn if you'd like to get involved in what we're doing. And I'd just like to end by saying thank you for inviting me to this session. Happy World Space Week. Brilliant to see you, Chris, after all these years. Chris is my lecturer back when I did my aero degree, and it's great to be involved in the event today. So thank you very much.
Brilliant, thank you. It's always hard being the first one on T-5. There's a lot of pressure getting used to it, isn't it?
Yeah.
Okay.
Thank you.
I'll just prepare the other slide here. So we have questions at the end for this particular session. So next we have Martina from Momentous Space. Let me just share my screen again. Now, Martina, are you there?
Yes, I am here. Hi, Ryan.
Perfect. So, Martina, there we go.
Fantastic. Hi, everyone. My name is Martina, and I'm a solutions architect at Momentous. I'm currently located in the Netherlands. Usually work out of Sweden, but I'm working with one of our partners here. So thank you, both Ryans and Remco, for organizing this event. First, I would like to dive into the vision and mission of Momentous. So we believe in a future where humanity is equipped with all it needs to flourish throughout the solar system. And our mission is to provide the infrastructure services that support all industry beyond Earth. As I'm sure many of you are aware of, the space industry is growing rapidly. So the space industry will be worth $2.7 trillion 30 years from now, according to Bank of America, Merrill Lynch. And I'm not sure when the next slide is showing, but there we go. The new space applications will emerge in the next decade, such as space tourism, space manufacturing, data processing in space, space power, and a lot more. And the space economy will also become less dependent on Earth as a lot of these new applications emerges. So it is truly an exciting time to be involved with the space industry, and I'm really glad to be involved with it myself. So I want to take a little closer look at space transportation in particular. The trends, as you can see here, are showing us that the amount of satellites launched each year is rapidly increasing. Satellites are also getting smaller, even geo satellites, to drive down the costs with launching them up to space. And this will require more and bigger rockets. And as you can see here, the development is steadily increasing with the size of rockets and the number of satellites that are being launched. So what is mainly driving this trend is the cost of the launch itself. So as the rockets get larger, it is also driving down the costs of launching to space. And the rockets are providing a cheaper price per kilogram. So there are a lot more opportunities for satellites to be launched into space. And as you can see in this graph here, going from $8,000 or $8,000 per kilogram, and then going all the way to Starship, where it's predicted to be $500 per kilogram. You can see on the graph on the right side as well how the cost per kilogram is decreasing. So this will make space more accessible and enable a whole lot of new missions. And space will eventually become the new source of wealth. So some examples are solar energy, construction and raw materials, propellant, rare and precious materials, microgravity. There are plenty of opportunities in space that will attract a variety of businesses and scientists that will contribute to the growth of this industry. So it will be very exciting to see in the next few decades all the new applications that will come to the market. Transportation will be the major enabler of the future of space, just like transportation has been the major enabler of other industries, such as the steam engine that led to industrialization, the turbine and aviation industry that created tourism, alternating current drove electrification, and the optical fiber that enabled the internet. So by reducing the cost, advancing the capabilities, and improving the reliability of transportation. And so momentous, so one of the current problems with accessing space is the launch vehicles go to standard orbits, and rideshare customers are often unable to achieve the orbits they require for optimal performance. And at Momentous, we decided to tackle this problem by offering a shuttle service to move spacecrafts from a standard orbit to essentially any custom orbits, which otherwise only dedicated launch vehicles would be able to provide. And the offerings that we have include the lowest cost alternative, enabling new missions, just like the ones I was mentioning earlier, expanding mission capabilities, and providing schedule convenience by having frequent launches to space, and environmentally conscientious. So we offer last mile delivery in space, essentially. After our rocket carries our transfer vehicle with satellites to the initial orbit, we will then continue to the ride to custom orbits and deploy the satellites. And you can see that in the figure here. So we do multiple deployments depending on how many satellites we would have on our transfer vehicle. We also offer a hosted payload service. So this is for different scientific experiments that can go up to space and be tested after we have deployed the satellites. So you can see that in stage 4 here. And then after that, we deorbit the transfer vehicle. And the shuttle service vehicles that we will offer are the following. So Vigoride is capable of carrying 300 to 500 kilograms of payload mass, and will initially provide services in low Earth orbit. And then Ardoride, capable of carrying up to 4,000 kilograms of payload mass, will be able to go to MEO, GEO, HEO, and lunar orbits. And then we had Fervoride as well, that will go to deep space. And in terms of rockets, we are compatible with all major launch vehicles. And these are just 2 examples of how the Vigoride vehicle can attach to an ASPA ring. So both for small launch vehicles and larger launch vehicles. So one of the services that we have is the charter service. So this is essentially one customer that gets the transfer vehicle for themselves. And this can then be launched to any orbit that they desire with any specifications. And then the other service that we offer is the shuttle service. So this is a rideshare service with multiple customers on the transfer vehicle, which means that we do multiple drop-offs to the custom orbits that the customers have requested. Our first mission was the El Camino Real mission in 2019, where we demonstrated our thruster technology. And this was actually the first in-space demonstration of a microwave electrothermal thruster, or MAT. And we use water as our propellant for this thruster, which is quite exciting. And the first transfer vehicle, as I mentioned earlier, is Vigoride. So this will have small sets mounted to the payload deck, and the CubeSat capacity is up to 96 units. And the first launch demo mission is in December this year, so just in about 2 months. And then you can see our launch manifest here, that we have another demo mission in 2021, as well as 3 other missions. And then it's increasing in 2022. And this is our current global presence. So we are in many places around the world, but we're hoping to expand that and get some customers specifically in Africa and South America as well. So thank you all for listening. I hope this gave some good insight on what is happening within the in-space transportation market, as well as an overview of the services we provide at Momentus. If you want to find out more about our services, or if you would like to fly with us, then please get in contact, martina.lofquist@momentus.space. And thank you as well to the SpaceUp team for organizing this, and happy World Space Week.
Okay, thank you, Martina. So next we have Rochelle Velo. So let me just bring up the slide. Just a minute. I'm switching here. Okay, just checking. I've got the transitions here. Yeah, that was fine. Okay, so Rochelle, over to you.
Hi everyone. I'm just checking that you can hear me and see me okay.
Yeah, loud and clear.
Yeah, perfect. So I'll just start by talking a little bit about myself. So I'm an academic medical doctor. I work in the NHS in intensive care, and I also am the Chief Medical Officer for the Austrian Space Forum. And I'd just like to say thank you for inviting me to SpaceUp Live. So in terms of what happens to the human body, we need to categorize it into three different elements. So what happens to the biology, the psychology, and ultimately the physiology. So that's the actual brain, your heart, your lungs, etc. And this is a great summary of what happens. One thing on a cellular level is that your genetics completely change, and that influences what happens to your organs on a macroscopic level. And specifically, I'm going to talk a little bit today about the brain, which really fascinates me, and I'm sure it will fascinate you as well as we continue this conversation today. So in terms of the brain, there are lots of different, and that we can easily measure using questionnaires, sociological observations, linguistic derivation. And there was a great duo in Italy, Valza and Folletti, who basically investigated together the synergy between neuroscience and the brain. So the neural networks within the brain are mirrored or symmetrical with the cosmic webs that we see. And this isn't just a trick that we see with our brain. It's not aphenia, but it is exactly what is there. So you can quantify the fact that the neural networks, the nodes, and the different relationships have, when you do power spectrum analyses, actually show this beautiful symmetry between the universe and the brain. So this slide basically shows you that the brain and what happens structurally affects the behavior. So what we started observing over the last 40 years, and NASA have an NTRS report about this, is that astronauts had a change in vision. So a change in visual acuity. They monitored this using lots of different techniques like the OCT and ultrasound. And we found that there was altered structure. So if you imagine this as an eyeball, we started seeing a flattening at the back of the globe. And this was probably due to a buildup in fluid and pressure around the brain itself. So what we're now developing and moving towards is thinking about more complex neuromonitoring systems to try and investigate what is actually happening in the brain itself. And the rest of this talk will just talk you through monitoring in general within the suit, within the astronaut suit, especially the Austrian Space Forum suit, and what we're working towards in the future to integrate with engineers into the suit to monitor our amazing brain. So this slide basically shows you that the analog astronaut, so this is one of our Austrian Space Forum analog astronauts with their rover, has a very closed in-suit environment. And there are lots of different elements of biotelemetry or telemetry parameters that we can measure as doctors and we see on screen to look at your heart, your lungs, etc. And we can go through this in more detail. But what we really, the essence of everything that we do is that human physiology can deteriorate unpredictably. And that's why we need different monitoring systems, like you can see on the slide, and different sensors to actually give us an idea of what is the cumulative score. And this cumulative score was developed basically to try and think about that distance between the flight surgeon, who's usually on Earth, and the astronaut. Because having a cumulative system or traffic light system display to actually monitor that their health is deteriorating and to think about interventions autonomously before the flight surgeon even intervenes. So the first half of the score is basically to look at simple things like your airway, your breathing, your circulation. So what I mean by that is we can indirectly measure what's happening to your heart, what's happening to your lungs, what's happening inside the helmet. And this is used in intensive cares on Earth, but it's modified to actually reflect suit physiology. The second half of the score then goes on to look at disability, which is essentially another word for what's happening to our brains. And we can do this in two ways. We can do this very simply by looking at someone and saying, are they alert? Are they actually talking to us? So that's voice. And you can score that and grade that. And these are evidence-based scoring systems that we use in terrestrial medicine. But in addition to that, we can also look at other parameters, like what is the thermal physiology, what else is going on? Is there another astronaut on site that has eyes on the other astronaut? And is there indirect neuromonitoring, which is what happens with suits at the moment. So we can assess indirectly what's happening to your brain. And this is very different from neuromonitoring on Earth, which is very invasive and requires bolts and screws and fMRIs and big devices like CT scanners that we can't take up to the ISS or with us to Mars at the moment. The other thing is that you can also look at EEGs, but again, these are bulky devices, and doctors need to work together with engineers to develop the next phase of neuromonitoring. And that in essence needs to be portable and integrate with your suit. So I'm sure a lot of you have smartwatches and Apple devices, and a lot of them work on infrared radiation to measure your heart rate and pulse oximetry. In the same way, we can measure what's happening in your brain, in your cerebral blood flow, using a technique called functional NIRS. And this is different from the ultrasound scanners that you see. And functional NIRS marries these two elements together. What's happening in the brain in terms of structure, but also what are we doing functionally? What movements are we doing? Are we piloting a spacecraft? Are we actually doing something that will affect these decisions affecting the rest of the crew? And in essence, the bottom figure basically shows you that. And throughout this entire process, as a biomedical team, we have to weigh up two things. We have to weigh up what is the risk of additional sensors, integrating them into the suit, and what is the therapeutic benefit, and is there any value added to us as flight surgeons when we integrate something like functional NIRS into a suit? And that's something that we're developing. So I'll just end there, and thank you for listening. And if you've got any questions, I'll have.
Okay, hello. Yeah, so thank you very much, Rochelle. So, and then next we have, I think we're a little bit behind schedule now for some reason, but let me just the next set of slides, which is for
Heidi.
So exciting new news today, which has just been announced. So do you see the slides? Yeah. Heidi, are you there?
Yep, I can see. Just let me know when you want me to start.
Okay, great.
Okay, hi there everyone. My name is Heidi and I'm here from the Space Skills Alliance to talk about something brand new, the 2020 Space Census, which is actually just launched today. So I'm really briefly going to introduce the Space Skills Alliance and then talk about the census. So we're a think tank and backbone organisation addressing the UK's space skills shortage. We were founded just over a year ago, and since then we've been working on tackling different aspects of that skills shortage that I've mentioned. So some of our work essentially focuses around evidence-based decision-making with escape data and skills needs and diversity. So some of our previous work has looked at the skills demands of early career space jobs in the UK, how these jobs are advertised, where they're advertised, and how well they're being advertised, and how much of a the sector of the space kind of population they might be reaching. So we're also working on other things like enabling better space careers through adoption of best practice, training, recruitment, and inclusion. So some of that work has been working, as I said, on assessing the quality of space job adverts and building a toolkit for companies to use to make sure that their hiring follows best practice and they're reaching a wide range of good quality candidates that can fill their roles, as well as reaching out to a wide community as possible. We're also building a powerful community of people to share data, collaborate, and learn from each other. And as a community, if we work together, we can actually make the space sector a better place to work and make it much more attractive to new recruits and people wanting to enter the sector. So I'm going to show you a stat next that I'm sure you'll know. The UK wants to have 10% of the global space market by 2030. But to do that, we're going to need to hire more than 30,000 new workers in the next 10 years, or 9 years even, actually, if we're counting the end of this year. And that is a big issue because we don't know who is in the space sector. We have a lot of data about the financial side of the space sector, the location of companies, what companies are doing, but we don't know anything about the people. And this means we actually have a bit of a data issue. We have very little idea about why people join or leave the sector, the people that make up the sector, whether they enjoy their job or whether they hate it, whether they've had training or whether that training has helped them in their career. And this also means that we don't know a lot about other things, but we do know that the space sector probably isn't very diverse, but we don't really have any actual statistics on this, which means we don't have any sort of existing baseline for any sort of diversity and inclusion work done. This means it's really hard to measure the impact of any interventions and measure whether the interventions are even effective. And this isn't just in terms of diversity, it's also in terms of skills provision and training to make sure we have that future workforce. So what's the solution? You may have guessed by now that it's actually a census of everyone working in the UK Space Force, or Space Force, space sector, but that's a new thing I've invented. So this is the part where I'm now going to introduce the UK or the 2020 Space Census, and I'm going to ask for you to take part in this important piece of work. It opens today and it runs to the end of the year, and your input would be really valuable. So the census itself is split into two halves. And in the first half, we ask about who you are, your experiences working in the space sector. So we basically cover the demographics and we cover most of the protected characteristics under law. We also ask about your experiences of working in the space sector, whether you've experienced discrimination or whether you haven't, and whether you've enjoyed your job. The second half of the space sector is actually about your job itself. We ask about your role, your company, whether you enjoy it and you feel like you have a good work-life balance, or whether you're actually considering leaving your role or leaving the space sector as a whole. We also want to understand how you got into the space sector, what your educational background is, and what inspired you to work in the space sector. Now, it's important to mention that the space sector is the space census is only open to people working in the UK space sector. So at the moment, we're not including undergraduates or space enthusiasts at this stage, but that may come down the line. The census itself is actually pretty short. It takes about 5 to 10 minutes to complete. It took me only about 4 minutes, so you should be fine. And it's totally anonymous, and all the questions are optional, so you only have to answer what you feel comfortable with. And all the results will be released publicly in early 2021 for everyone to see. So I imagine you're not going to be able to read these quotes on the slides in just 15 seconds, but I just want to highlight the fact that we've had a lot of support from industry and academia. And this extends to a range of companies and groups within the sector, which you'll see on the next slide. And the results of the space census are going to be used by all of these different groups to inform national policy and space sector strategy. So this is going to feed to the Space Sector Council, the UK Space Agency, and other groups. So what I'm asking you from this very short talk is that I would really appreciate it if you would take just 5 minutes out of your day to fill in the census and share it with your colleagues and friends within the sector, especially those who aren't watching on YouTube or stay on Twitter and keep up with all the space gossip that way. But we want to make sure that we get responses from every corner of the sector, from system engineers to biomedical researchers, from astrophysicists to space lawyers, from HR directors to space journalists and artists. And the more people who fill it in, the better understanding we get of the sector. So please go to census.spaceskills.org and fill it in, and I'll drop the link in the chat. Thanks very much.
Thank you, Heidi. So, yeah, I think, as I said, we're just a little bit behind schedule. So thank you. I know a couple of panelists are sort of waiting there. We just have one last T-5 before the Q&A. So we're about 5 minutes behind schedule, I think, here. So next up, we have Natasha Alden from Multiply Space. So I will just share my screen again. And Natasha, if you're there, yeah.
Yeah, great.
Thank you.
Thank you. Hi, great to be here this evening. My name is Natasha, and I'm looking forward to talking to you about technology transfer, which is a key element of how satellites improve life here on Earth, as well as support and sustain the UK space sector. I founded Multiply in 2015 to unleash the potential value of technology by working on technology transfer programs. So this is hardware and software, taking technology into new markets and new applications to drive commercial revenue and build sustainability. Since we started, we've worked with a whole range of clients across advanced engineering sectors, but we specialize primarily in the space sector, spinning in and spinning out capability. To give you a bit of an idea, we've worked on technology from taking heat transfer capability from rocketry, transferring it into electric vehicles, leveraging nuclear robotics for in-orbit servicing, taking radar and Earth observation data and applying it for DNO and infrastructure. So very broad. It's all about designing and delivering B2B technology transfer programs and ventures. We've realized over £30 million of opportunities since we founded in 2015. And it's about providing a low-risk route across our 3 service pillars, which I'll go into more. And as I said, taking the technology into new markets and new applications, or in some cases, through new business models. One of the areas we're specifically seeing growth in at the moment is around AI. So how do we do this? The first pillar, service pillar we provide is our technology transfer sprint. This is an 8 to 12 week sprint that gives you a technology transfer plan and strategy at the end of that 8 to 12 weeks. It's about understanding the market, defining the propositions, really understanding the viability of your technology and the right to play. And it's about engaging industry early on. Our technology transfer build is all about delivery. This is where we go and source the funding for you. We build the consortia, lead the programs, engage with the customers, and take you right through to demonstrator, early market, or pilot. For us, it's about building long-term relationships, not just providing a report. It's about delivering financial results at the end of it. And our third pillar is multiply technology. This is where we incubate ideas or IP that have not been looked at before in terms of a commercial or exploitation route, and we run concept through to prototype. So the team, we're a relatively small team at the moment. We're scaling very fast, which is fantastic. Myself and my colleague Clarice are the primary directors leading the program. Clarice specializes in our partnership and operations, and we've got a very active board behind us that are key to supporting the vision and realizing the ambitions. And critical to what we do is how we do it. So we have a proprietary framework that we've developed over the past 10 years. This is based on design thinking from the digital sector, but applicable for technology transfer. So how to rapidly, but with quality, actually deliver technology transfer programs. So we recently published our study into B2B technology transfer into the UK space sector. And we did this because we noticed some trends and we had some assumed benefits. And what we found was that our hypothesis is that, yes, tech transfer can improve resilience, create sustainable growth, and have a positive impact on society and economies at large. This study was actually over a whole 2-year period, but we did well over 100 hours of secondary research, industry feedback through interviews, and public response. Majority was based in the UK. We had some overseas interest as well, with the majority of respondents in Midlands and South East. And what we found is that there is a huge opportunity to improve the return on investment for GVA. Okay, so the gross value add, the moment you're looking at £3 to £4 return on £1 invested into space innovation, more broadly, that can be up to £7.30. And there is an opportunity to bridge that gap. Yet, despite this, 82% of UK space companies aren't proactively doing technology transfer. And this was very interesting. And we found out, well, people reckon there's definitely an appetite to do this. There is a need. People understand that there's a huge opportunity for revenue growth, to demonstrate innovation and leadership and get learnings to feed back into the business from other markets and applications. But the barriers that are there is a limited bandwidth, a perceived or actual lack of skills in the business, which is stopping a lot of companies from maximizing the value of their technology. So from the study, we have 3 core recommendations. And the first is to undertake further research, go to another level of granularity and help design what sort of support mechanisms and policy developments do we need to put in place to really raise the profile of B2B tech transfer and get broader value from industries. The second key recommendation is obviously the policy development through roundtables and showcasing. We are actively engaging with government on this at this stage and continue to do so. And the third is with the vision of being able to put in place the right support mechanisms, be they kickstart grants, voucher schemes, loans, to be able to address those barriers to tech transfer and again, realise the value from it. This is what we're taking to government, and we want you guys to get involved. We want to hear your thoughts, your feedback, your experiences, and as an industry, be able to help engage government and drive support that will ultimately lead to more sustainable and resilient industry. And also for you guys to reach out if you're looking to start your technology transfer journey, be it a new one or you've done it before, not sure how to, what applications, what markets can we do it? That's exactly what Multiply is designed for, and we'd love obviously for you to reach out. My details are obviously on the screen. I appreciate we've only got 15 seconds of them, but if you just type in Multiply Global, Multiply Space, we should come up on Google, and look forward to hearing thoughts. And thank you again, and happy World Space Week, everyone.
Thank you, Natasha. So, yeah, so that was, I think, our last talk there. We are a little bit behind schedule, so I don't know where we are with questions here. There's quite a few things going on in the chat there.
I don't think there's any actual specific questions there at the moment.
Yeah. But yeah, there's a lot of discussion in the chat there. So yeah, thank you very much again, Natasha. So yeah, next we have our panel. So as I've been on the call here with just to check we've got everybody. So we have Michelle Mendes from Satellite Canada, Executive Director, Agnieszka from Planet. We have Daniel Porras from Secure World Foundation, and Emma Taylor, so past chair of the Safety and Reliability Society. I invite each of the panelists just to give a very, very brief sort of introduction, so about 30 seconds, just to just to kind of introduce yourself and sort of how you say hello on the chat there. So yeah, so first to Michelle. Hello, Michelle.
Hi, how are you?
Good, thank you.
Good. I've been listening intently. This is a fascinating event. I've never been to a SpaceUp event, so Remco would be slapping my hand right now. I know. So I've known Remco for several years. I'm the former executive director of World Space Week, so happy World Space Week Association. And Remco was the executive director as well. So I'm now the executive director of Satellite Canada Innovation Network, and we are, the closest thing that I can call us is a program deliverer or space industry association. So what we do is we grow the Canadian economy for Canadian space. We try to import import international goods and export Canadian goods. So we try to help Canadian companies do that. And we also provide a soft landing for companies that are interested in doing business in Canada. So we work with various stakeholders. We work with the Canadian government, we work with international governments, we work with international companies, we work with Canadian companies, we work with startups. So we work with a whole host of stakeholders to build the Canadian space economy in an effort to build the global space economy. So I'll leave it at that and pass it over.
Thank you, Michelle. So next we have Agnieszka from Planet. So Agnieszka, over to you. Thank you.
Hi, Ryan. Hi, everyone. Thank you for having me. This is exciting. This is also my first SpaceUp event, believe it or not. So that's kind of crazy. I've been involved with Space Week, though, for many, many, many years. I don't even know how many, but many. I'm on the board of Space Week. And I know Ryan also for many, many, many years. I work for Planet. I'm a senior director for European Affairs at Planet. I'm normally based in Brussels. I work on government and policy issues related to Earth observation. So Planet, as some of you may know, is the largest satellite operator in the world. We have a mega constellation that is able to observe every place on Earth daily. And we do that for environmental purposes, security purposes, all kinds of different reasons. And the co-founder and CEO of Planet, Will Marshall, I believe, is the alum of University of Leicester. So there's a connection there as well. Thank you.
Thank you, Agnieszka. So next we have Daniel Porras from the Secure World Foundation.
Hi, everyone. Good to see you. Ryan, many thanks for having me on. Agnieszka, good to see you. It's been a long time. My name is Daniel Porras. I am the Director of Strategic Partnerships and Communications at the Secure World Foundation. We're an organization that works to ensure the sustainable space activities, essentially that we're going to be able to continue using outer space the way we've been enjoying it for the last few decades, for the long term and foreseeable future. Additionally, I am the former space security fellow from the UN Institute for Disarmament Research. So my background is actually all about how we disable or even destroy satellites and different ways that militaries are coming up to try and counter space-based capabilities. So very excited to be talking about some of these issues and how some of that could be impacting the services that we have every day.
Thank you, Daniel. And finally, we have Emma Taylor. So Emma is a past chair of the Safety and Reliability Society. So Emma.
Hi, Ryan. I'm assuming that I'm coming through okay. So thank you very much for the invitation and the opportunity to speak. This is my very first SpaceUp Live event, and it's also my very first World Space Week event as well. My space career started about the time that an organisation called UK SEDS, which I'm sure many of you are familiar with, back in 1989. And since then, I worked in the space industry and in energy and also in transport. So the Safety and Reliability Society, possibly a very appropriate acronym for like this year, SARS. And we are a professional engineering institution that looks after all disciplines of safety and reliability, from space through to aviation, through to nuclear energy, and even like sort of theme parks. Anything that involves safety and reliability, sustainability, and resilience of society and engineering. And we are a charity, and we're also regulated by the Engineering Council. And our remit is to make the world better and safer for everyone. So leadership in the field.
Thank you to all our panelists. So that's a bit of each of our panelists. So what we're trying to do in this panel is linked to the theme of World Space Week, which is about how satellites improve life. We're going to imagine a world without satellites. So what would the modern world look now without satellites? And what's really the different impact on finance, business, safety, and rescue? So I mean, maybe first I turn to Agnieszka. So as you say, Planet is the largest sort of satellite operator. So what do you think? What would the world be like without satellites? Without Planet, maybe.
No, I know Planet is not everything for sure, but it's an interesting question. It's an interesting question. I mean, obviously, the answer is obvious for us, but we are in this little space bubble, and the answer to that is not obvious pretty much to everyone else. So I answer this question pretty much every other day when I'm in an Uber or a taxi or a restaurant or a bar where somebody asks me, oh, what do you do? And I say, I work in the space sector. Ah, such a waste of money. We're in the middle of pandemic and economic crisis. Why would somebody spend money on space, right? This is what people say to me. So usually what I say to them is like, well, imagine the world without satellites. And many of them can't quite do that because they don't really know what satellites do. Most people know about GPS. So they know about navigation because they have it in their car or in their phone. Some people maybe can think about satellite TV, telecom maybe, and this is how far as we go. So things are quite more complex than that. And right now, satellites are providing so much input and information to not just the decision makers, but to society in general, that I think not having them would be a big gap. I don't think we would be would have the same awareness about climate change and environment and what is happening around the world in terms of deforestation, for instance. I think the bird's eye view. It really gives you an awareness that you don't really normally have. And because there's satellites are always there. With planes, you have to make that flyover. Satellites are there. You can really compare things from day to day, especially, I mean, I'm going to brag a little bit about Planet's imagery, but I think this is what makes companies like Planet useful, is two reasons. One is that daily imagery can really show you a progress of either positive progress or progress of deforestation or something bad happening on the ground, because you see from day to day the changes that are occurring. So you can really monitor and flag things. You can also, I don't know if you know this, but like majority of deforestation is actually happening on single tree level. So with low resolution satellites, actually, you don't really see it much, because it's not like one big area is missing all of a sudden. You know, they're cutting a tree here, tree there, tree over there. So it's really a combination of Earth observation, of high resolution Earth observation, artificial intelligence that is able to count these trees, is really giving information of what is happening. Another thing, you know, that we are also giving citizens information about what is happening in the world, in terms of conflict, and in terms of atrocities and human rights that perhaps an average citizen would not have an access to. So I have an example, for instance, of, you know, the burning of villages in Myanmar, of Rohingya villages, and the government was denying this for a very, very long time. They said that they were not really doing anything, and we're like, boom, well, we actually have a picture. And not only we have a picture, we have a video that is showing that you are indeed burning these villages. It's not just one village, it's many villages. And you're doing that, you know, on a continuous basis. So I think that sort of awareness, we have that sort of motto at Planet, the company, is to have a transparent planet, meaning planet Earth. So more we know, or more we aware, better decisions we can make, but also we're less likely to be, and perhaps Daniel can elaborate on that later, but if we know that people are looking at us, that we're being observed, we're less likely to do shady business, right? Because we know that we're being looked at. So that kind of also offers a certain accountability, I think, that maybe without satellites we would not have. And I'm not even, because I will also, of course, let the other panelists talk, but like the sectors that are impacted by satellite technology today are, I mean, the number is huge, and I think we're just scratching the surface. So I think there are two questions that are interesting to us to ask. One is, what would be life like without satellites? And the second question is, what would be life like if we actually use the full potential of satellites, which we're not doing that yet. So thank you.
Thanks, Agnieszka.
That's brilliant. Thank you. So I've got a question for sort of all the panelists in turn, actually, and it kind of rolls on nicely from your answer there. But it's kind of, as you said, it's quite obvious if satellites were to disappear tonight, what the impact would be, right? You wouldn't have GPS, all those obvious things everybody thinks of. So my question is, in turn, what is the least obvious but significant impact satellites disappearing tomorrow or stop working tomorrow would have on our day-to-day lives? So maybe start with you, Daniel.
Sure. Well, there's one of the things that I was going to follow up on what Agnieszka was talking about, is that actually up until this point, and this of course coming from the UN arms control background, is that we use satellites to monitor strategic arms. The United States, the Russians, even the Chinese to an extent, the way they keep an eye on each other and make sure that they're not violating or going beyond certain activities or certain limitations on nuclear weapons. A lot of that is confirmed through satellite observation and verification. So even the nuclear balance that we have in the world in terms of geopolitics is largely based on satellites. And then to bring that home a little bit more to something that maybe everyone else here could relate to is finance. Many of our banking transactions are based on time signatures that come from the atomic clock located in GPS. So if we had a massive outage of GPS today, it would literally have an impact on every banking transaction that we have around the world, or at least the ones that are dependent on the GPS system. Now, it's a good thing that we have multiple global systems like that are redundant, and hopefully these different systems will be able to work with each other to provide layers of redundancy. But there can possibly be incidents of space weather, for example. We've been monitoring, humans have been monitoring now a lot of solar activity in the anticipation of having a big solar flare that could potentially disrupt a lot of our satellites. And we don't know yet what the impacts could potentially be. Some folks are preparing for it and trying to harden their satellites so those things won't happen. But we're not going to know until it happens.
Brilliant. Thank you for that, Daniel. Now, I appreciate the answer to that question get harder and harder the more people answer. So Michelle or Emma, do either of you two want to go next?
I'm going to jump in. I'm going to take the easy slot, because you're right, the fourth person there is going to find it quite hard. I'm going to take it from the point of view of energy security. So for people that work in the safety and reliability field, our day job is to imagine all the things that could go wrong that other people maybe don't think are credible, and then put in measures so that they don't happen, or if they do happen, they cause less of an impact on society and on business. And one of the key areas where we really are dependent is energy supply. So up until recently, there was one organisation off the coast of Hull in England, which was responsible for buffering and storing the majority of the UK's gas supply on a daily basis. And so if there were any sort of impact to the operation there, you would notice it pretty soon. There are big pipelines that run between the UK and parts of mainland Europe, carrying a large proportion of the energy supply. So what connection has space got with this? Well, these facilities are offshore. They're strongly dependent on communications, and they're also strongly dependent on monitoring and remote sensing. The sensors will pass information. The publication of data allows you to avoid, like with your ship, from crashing into an offshore rig. If you take away that flow of information, pretty much people are going to start operating blind. So you might not think of satellites leading directly to energy supply, but I think if there was a loss of communication, a loss of information fidelity, a loss of digital sort of security, things would grind to a halt pretty soon.
Very interesting. So you got the hardest task of all now.
That's okay. I am going to say, Daniel, with the financial aspect, when people ask me that, the first thing I ask people is, how much money do you have in your wallet, cash, right now? And usually people say, $10, $20, exactly, right? So think that that's going to be all the money you have until there are satellites up there. So you have $10 to live on for the next 6 months because you can't access your bank account and all these other things. And then in the same stream that Emma was saying, it's about transportation as well. Now, COVID notwithstanding, I understand that we're not doing a lot of that right now, but how safe would you feel getting into an aircraft or getting into a ship or getting into a train even without the navigation systems that are out there to make sure that everything's running on time, everything's not running into each other, and for those long haul flights, having Wi-Fi on your flight. So those are the things that I know Wi-Fi on your flight tends to keep people sane. The one that's the most important, I think, and I don't know if this is because I'm from Canada, but for us, we have a huge landmass up here. And most of our country is reliant on not fiber. We are reliant on satellite communications. This is one of the reasons why Canada tends to be quite good at the satellite communications biz and the, and the Earth observation. So it would really be a hardship for all, I would say, except for the people that, like me, that live in downtown Toronto and in the cores, the communications and the lack of communications would really be a hardship. I mean, we saw what happened when communications went down on September 11th, right? Nobody could contact, there was mass chaos. So having that communication that we're all used to, and even more so now, people freak out if they can't tweet somebody or they can't, post their Instagram and I know that that's not life-threatening, but, people are highly reliant on, I need to know where my kid is right now, right? So I think the communications part would be the most impacted up here, and the money.
Brilliant. Thank you very much. Agnieszka, I know you sort of covered sort of the answer to this question in your intro there about the setting fire to villages, and to be honest, that's an amazing story. But do you have anything to add before we move on to some more questions?
No, let's move to more. I know we're running late, so let's move to next question.
Okay, brilliant. Just a heads up to the audience, if you do have questions for the panel, then please feel free to put them in the YouTube chat, and we'll hopefully get to them. But in the meantime, Ryan, do you have any questions?
Yeah, I guess a question maybe for Emma. So, I mean, we're going more towards like greater connectivity. The next step is 5G, Internet of Things. So with all that increased connectivity, how can we build in that the safety reliability side that would basically ensure that if the satellites got knocked out, maybe by as Daniel sort of was describing, like a Carrington style event, so where solar flares sort of hit, and which I think is we're overdue, I think, for a Carrington event. How do we ensure this the actual connectivity there beyond, like, how do we plan for that resilience and everything else that fits with that,
along with everything else that's happening on the planet? It's a very interesting question, and I did note that, like, Daniel was also part of the business that was looking to blow up satellites, and I have to say, from the safety and the ex-space debris person side of me, I was like, going to be, don't do that. You blow something up, it's going to be there for quite some time. So now I've finished naughty stepping Daniel, I'll come back to the question. I think it's interesting because people think about, like, the flow of information from a network of satellites, and you can design a constellation so that you've got redundancy. You can design it, if you lose one, you're still able to pass the signal around. But I think there's a subtle point that people are sort of less aware of, is, can you assume that the information you're getting is the right information? Do you have missing data? Do you have fake data, spurious data? Is it incomplete? Is it just plain wrong? And, like, the data fidelity, the data checking part is becoming more and more important. So not only just the point of, like, is the satellite going to be there to transmit the information, or is somebody going to be able to take hold of that data stream and modify it? Or are there inherent design or software flaws that are causing the data stream itself to be modified? Because we make so many decisions based on the information that we receive through the satellite network. GPS is just one example, the onboard monitoring. And if that data stream starts to get corrupted for malicious reasons or by accident, pretty much you're going to have the equivalent effect to a satellite being knocked out, but without a satellite physically being removed. So all I'm doing is worrying you. Safety engineers, our job is, like, to imagine all the things that could go wrong. We're basically negatively positive. So not only physical loss of infrastructure, but digital information infrastructure loss.
Emma, you do what lawyers do. You hope for the best, but you prepare for the worst, right?
Absolutely, absolutely, yes.
I can say I'm married to a lawyer, so I say that in sort of jest.
Okay, we've got a lot in common. Colleague, I'll just interrupt, because if you ever find a safety engineer that's sitting there and saying everything's fine, we've been taken over by aliens. The definition of a safety engineer is to sit there and say this could go wrong. So whenever you've got one of us on your team, we're there to be negative. I'll pass back to Ryan now and be quiet.
Actually, if I could just follow up on that, to go on. First of all, I do need to clarify. I'm not in the business of destroying satellites. I'm in the business of preventing the destruction of satellites. The main program that I work for is the prevention of an arms race in outer space. But one of the things that we've also been looking at specifically on this issue, it's not just affecting the satellites, but there are certain capabilities that they don't target the satellite, they target the terminals down on the ground. So you can actually, cyber capabilities and even things like jamming or spoofing signals can be really big problems, especially as the Internet of Things starts coming online. One of the biggest challenges that I've seen thus far with ground-based terminals is for automated cars. Agnieszka and I have an old colleague named Attila Matas, who used to work at the International Telecommunications Union, and about 2 years ago, he did a demonstration where he showed how a GPS signal can be spoofed with about $80 worth of gear that you buy on Amazon. It's actually pretty simple. And the question was posed, well, what happens when all of our cars become automated? Somebody decides that they want to stand on the side of the road and turn on a signal that will essentially tell your GPS, hey, you're 5 feet or 5 meters too far to the right, you need to scoot over. We're about to become very dependent on some of these infrastructure networks. And so we need to be thinking about how we're going to protect them and how we're going to make sure that, one, we don't have safety issues, but also, two, we don't have security or intentional harm issues.
Brilliant, thank you. We do actually have a question from the audience now, which is great. One from Heidi. What's the biggest risk to satellites now? I know CMEs have already been mentioned, but sort of what others are there apart from CMEs, really? I don't know, you've mentioned also spoofing as well, but that's kind of a bit more direct, I guess. Yeah,
it's debris. Space debris is probably the biggest threat that we have at the moment, because we're not totally sure how much of it is up there. We have good estimates up to 10 centimeters and pretty soon up to 2 centimeters in diameter. But even something the size of a ball bearing traveling at those velocities can be very harmful for satellites. That's why we don't want to blow up satellites.
Probably a continuation on that. There's this term Kessler syndrome that's often sort of across like collisional cascading. I mean, how much of a risk would that be to this wider kind of communications? I mean, that is, I think.
Can I bring out a piece of satellite with a hole in so everyone got to get a sense of the scale of what a small piece of junk does?
Yeah.
I mean, this is just like this is actually from like EnviSat, which is one of the largest satellites in orbit, probably launched the size of a bus. This is the front. You can probably tell the size of the hole as my little finger. That was done by something that was 2 millimeters across, so fairly small. This is the back, and basically when it was tested, it blew the back off. So there we are. There's your calibration of what a small piece of space junk can do. So I'm fully with Daniel on this one. Space junk, space debris is our biggest problem.
I see that's the Impact Lab at Kent there.
Yeah, that's an orbit for my PhD. So it's always handy to have a bit of spacecraft with a hole blown in it to the left of you.
Just looking at some of the other questions. Let me see. From Jeff, is the satellite business becoming more resilient as the world becomes more reliant on it? Maybe Daniel, looking at the secure world.
I would actually also push this back to Agnieszka, but the mega constellations are one innovation that we're definitely seeing, that some of the services are trying to be more redundant. If you just have a couple of satellites or even just one and something happens to it, then yes, your service is probably going to be critically damaged. However, if you have hundreds or even thousands of satellites that you're just replacing continuously, then you can lose a few and it's not that big of an issue. However, we do need to be careful about how much stuff we're putting up there, because despite the fact that outer space is quite large, Earth's orbits are not. They're finite resource, and we need to be smart about how we use them. Agnieszka, maybe you want to say some more about that.
Yeah, sure. No, it's absolutely right. I think it's, the mega constellation business model, it kind of operates in the economies of scale type of model. So indeed, a loss, it's, we actually have a example, a recent example. We were launching, I think it was 4 satellites on a Rocket Lab launch in June. That was that rocket that blew up. So we lost those 4 satellites. And I mean, that was very unfortunate, but that didn't really impact our business in any way. If you look at these, huge satellites where, for instance, I don't know, you look at Copernicus program where in total there are 6 or 7 satellites. If you lose 4 of them, then you're in big trouble. So definitely that is that is a different way of looking at things in terms of.
I'm good, thank you. I'm just finishing something off here.
I hear some background, somebody's talking in the background, so maybe you could mute your so in terms of like being a responsible space actor, I think this is absolutely key, what Daniel was talking about. Mega constellations, some say that mega constellations are the biggest threat, actually a bigger threat than debris, because we're putting more and more stuff in space. that area, that especially low Earth orbit and geostationary orbit, I mean, are quite, are limited, and there's only so much we can do. So I think it's extremely, extremely important to educate those operators and have them to behave as a responsible space actor, because we are in this together. If we want to utilize this space for a long time, it is in our interest that we take care of it. And I would almost argue that the biggest threat to like the sustainability of space and to satellites is not really debris in itself. I mean, it is the debris, but it's the fact that we don't have any norms in place or rules or best practices to actually avoid a creation of that debris, or avoid a certain behavior in space. There's a lot of initiatives, a lot of people are talking, but nothing concrete yet is out there. So therefore, you have these mega constellations. You have, Elon Musk launching lots of satellites in bulk. Jeff Bezos is about to do the same, and we're not talking like Planet. We have like maybe 150 in total. These guys are talking in thousands. So they can do whatever they want, because there's not really anything in place that would govern that sort of behavior in space. So I think that is something that is going to have to be put in place sooner rather than later, although in the international environment it's extremely difficult.
Brilliant, thank you. So kind of move a sort of continuation of what you just said there. I know any satellite that goes up has to have an EOL end of life plan to deorbit it now. But what more can be done in terms of legislation, rules, in order to help protect the satellites we've got and still allow for continuing development of the near space environment? Kind of an open question to anyone who wants to take it there.
I'll pick up on the legislation point of view, because anything that like has got the potential to cause harm to people on like sort of Earth-based is subject to legislation and regulatory activity. Anything that's caused a major hazard, a high hazard activity, so like nuclear, energy, transportation, are regulated. And space launch, as you all know, is regulated in the same way. But I think picking up what Agnieszka was saying, the kind of social norms, the cultural norms, also the legislative norms are not as firmed up. So we're at the point there where we're probably going to, unfortunately, have to wait for something to go wrong for there to be like an irreversible event which has got a noticeable impact on other people's operations before the people, the organizations, the national governments, the legislate are going to get and react. We've seen this in many other sectors. It's taken, for example, Deepwater Horizon, major sort of oil explosion and spillage to create a change in the way that, like, for example, in Europe, you legislate against pollution. It's multi-fatality events. 737 MAX, the Boeing situation, that's what then caused the aircraft to be grounded and the software issues to be identified. So looking across sectors, unfortunately, it's usually reactive following a major incident. I would really hope it isn't, and I hope that organizations such as the people around on this table on the call are trying to proactively get people to take measures. But I think it's probably going to have to change following something significant. I just hope it doesn't involve loss of life, really.
Yeah, if I can add to that, unfortunately, I agree with Emma. I wish I could disagree, but I think, I mean, it's a human nature. We usually learn the hard way, we're going to neglect and avoid and be in denial for until something bad happens, unfortunately. And this is the kind of the tragedy of the commons. The launches are regulated, but what happens in space, it really isn't. Space doesn't belong to anyone. It's you have Outer Space Treaty, and which is super old and not really adequate to the current situation. It's pretty much impossible to have a treaty in place now, given the geopolitical situation in the world, and knowing that the major players like US, China, Russia, Europe can't really get along on anything. So we can talk about possibility of a soft law, so some sort of norms or code or best practices that we put in place. And there are initiatives out there, and I'm sure Daniel can tell us more about it, because that's what he does daily. I mean, deals with it. But there are lots of initiatives out there. But there, I do have to say that I don't quite see a light in the tunnel yet, because there's a bunch of blah blah that hasn't really gotten us anywhere yet.
Yeah, and I absolutely agree that nothing is. It's most likely that nothing is going to change until something really bad happens, and likewise, fingers crossed that it's not going to involve loss of life. It's also important to remember. You said that deorbiting plans have to be put into place when satellites are being launched. Sure, that's the case in some jurisdictions and in some countries, but we're getting more and more space actors all the time, and many of the emerging space actors don't necessarily have plans in place. And any country is able to launch a satellite. Everyone, the principle of free access to space, it's something that's been enshrined in the Outer Space Treaty since 1967. I don't agree, by the way, that the Outer Space Treaty is totally inadequate. I just think it needs a little bit of massaging and possibly some trimming down here and there. But unfortunately, we don't have a system in place that will manage all of the space activities because we have to come up with some kind of an international agreement. There are some efforts currently at the United Nations level to come up with norms or with different types of soft law agreements. So these would basically just be kind of just guidelines, things that it's not necessarily a law that you have to follow these rules, but everyone says, because we recognize that it's in our best interest for everyone to abide by, say, traffic rules, let's all agree that we're going to follow these rules. Unfortunately, again, as Agnieszka said, politics are just really tough right now. And because outer space is something that people don't see every day, because it's sort of out of sight, out of mind, a lot of the initiatives just cannot get, they can't get enough momentum going to actually become a longstanding guideline. Worse, in the political world that we're in today, it seems to be the case that people are transgressing norms that have been in place for a really long time. So it even makes me wonder there, if we do come up with norms, what makes us think that a lot of the state actors will still abide by them? So it's a difficult time, and a lot of the work that we're trying to do is just get the different stakeholders to understand it's in everyone's best interest to try and be a good, responsible actor.
Yeah, and if I could just come in here, I do understand that at the UN level, they've been working for a very long time to try and normalize responsible behavior. This has been a very unusual 4 years. I don't think I'm saying anything that anybody, it's been a very unusual 4 years. And politically, getting everybody to say the same things and normalize the same things is very challenging. Where space really has an advantage, and I've noticed this on a political level, not just in Canada with the United States, but with Canada and Europe, is that by using space as that olive branch of we are in this together, that this is one of the ways where we can work together and it can be depoliticized as much as possible. I think that space really is a tool for that. And so for us as leaders, and I specifically look to the Secure World Foundation regularly to provide that leadership. When I was executive director of World Space Week Association, I did a lot of work with your organization, and it really is the global leader in securing space for the world. So I do think that there needs to be a leadership acknowledged there somewhere, and at the UN, I know you do a lot of work, but I think that we can all gather people together, and I'm not trying to sing Kumbaya here, but space really is that place in politics where I have seen politicians come together. So hopefully, if we can bring things down from the UN level at agreement down to the policy level at the national level, I think that could be very, very helpful. And the dominating force at the national levels could reiterate that through the newer space emergers. So I'm very encouraged by what might happen, despite the other political things that are happening out there.
Brilliant. Thank you, everyone. I think I've got another question. It's slightly off the strict topic, so I'll let Ryan go if he's got a question. Otherwise, I'll ask it.
Well, I was thinking of like major events, and one thing actually is like 1989, which is in Quebec. So possibly Michelle might know a bit more about this. It's got an example in Canada, this major solar flare that hit. So this is actually real life sort of scenario that happened. And, you know, the effect now, obviously, since 1989, we've got many more satellites, more connected than ever. Perhaps with that real life scenario, like what lessons maybe has Canada learnt from this, and as far as our world with satellites and communication?
Yeah, that's a very good question. That example has been pointed to a lot whenever we have to educate, whether it be politicians or the public or kids about, you know, this is what space means. We point to that. There were extreme outages, particularly in the rural and remote areas. So most of our country is remote. And the only way that hospitals were functioning were through satellite communications. You know, I mean, I don't know if anybody knows this, but I mean, the health system in the remote areas, women still have to travel at 8 months pregnant to go and have their baby in a hospital. There's no doctor just there. So there were several deaths in multiple hospitals because there was not enough supplementary infrastructure to counteract that. And this is often cited as we have got to get our infrastructure in place, you know, not just so, you know, somebody in Nunavut can play, you know, their video games with their friend in Toronto, but this is so that, you know, these are life-saving services that are required. And when you take a look at places like Russia and Africa, and various places in the Middle East, South America, these are areas that can't be serviced necessarily with hardware. So having that kind of connectivity in Canada has become a very strong priority, and we've been able to develop and evolve our infrastructure here. I live in a place in downtown Toronto, and I have 5 hospitals around me. So if you hear a siren, that's what that is. But the entire city could lose their power. But there is such a resilient infrastructure in this part of Toronto because of the hospitals that our building never loses power. So that's one of the things that has improved since that time. So I would, you know, I look at that, and I would encourage other nations to look at it as well, because it's very possible for everybody.
Thank you.
Brilliant.
Thank you, Michelle.
Thank you. I think we're kind of running a bit low on time, so if I can just ask each of you one quick last question to wrap up, if that's all right. So we've kind of looked at what the world would be like without satellites at all. That's been very interesting and eye-opening, actually, in terms of, you know, how much more risk we would be in, and how our lives would be different. But I want to think now, 10 years in the future, we're 2030. What key thing about our daily lives will be different due to new satellites in the next decade? As in, when we look back from 2030, what would be missing out on without satellites compared to now, if that makes any sense? The silence says it all. Okay.
I'll give it a
go first.
No,
sorry.
Please.
I think, you know, I don't look at and I don't think we should be looking at satellites as, you know, what would life be like, or what would be like without satellites. I think I look at satellites more as tools for other things. So it's not the end, satellites, it's the mean, right? So My biggest concern right now is sustainability of planet Earth. I think this is what I'm worried about. So I'm worried about climate change. I'm worried about loss of biodiversity. I'm worrying about crazy weather phenomena and all of these things that are happening right now. I mean, we're in the middle of pandemic. And so I am looking at how satellites can actually help with that, how satellites can actually be a useful tool. So I don't want us just to build this fancy technology because it's fancy and it's cool and because we're nerds. I want to build it because it actually solves world's problems. And I think this is what, you know, people outside of the space bubble are really interested in. They're interested in solutions. They don't really care where it comes from, if it comes from satellite or a drone or a plane or whatever else. So I think we need to think that, have that mindset, you know, how can we address current world problems with that really cool technology that we have. And so that's what I would urge the space sector to do. So any sort of new developer, any new startup should really keep that in mind. You know, we have actually looked at sustainable development goals at Planet, and we've identified that 13 of them can be out of, so there's 17 of them, and 13 out of the 17 can actually be helped with one way or the other with Earth observation alone. So in 10 years, now going back to your question, I want us to be at the level where decision makers and society appreciates and funds and understands the value of satellites, and they are considered as a kind of a basic commodity that is well funded and that everybody can utilize in order to address these various world problems. So that firemen, for instance, have access to space data, or first responders, or farmers, you know, that it is not a rocket science, but it is something that is really like, just as we use internet every day, somebody could actually have access to data coming from satellites and use it towards something that makes his life or the community's life a little bit better and easier. So this is where I would like to go in the next 10 years.
Brilliant, thank you. Does anyone else want to take on that question?
I'll give it a go. I'm sort of following on from Agnieszka with like the UN Sustainable Goals. I think that in 10 years' time, people will recognize and value space and satellites and be aware of it in the way that they're not right now. If you go back 10 years from now in the past and think about how people were not talking about climate change with the way they are now, there's been this kind of sort of global sort of switch on. People are aware of it. They're more aware of like sort of like, you know, our vulnerability to this. And I think in 10 years' time, I think people are going to be more aware and switched on about space. So maybe it won't be like new technology or new systems or new constellations. I mean, space is space and physics is physics. There will be improvements, but no major step changes. But what will change is society's perception and understanding and appreciation of space. And I'm sitting here looking at the list of the UN Sustainable Development Goals, and I reckon I could probably do like the other four, Agnieszka, that you're thinking about, to add to them, space in some way, form or another. It's no more, no less than a key technology that is actually keeping this planet running in some ways at this time. So yeah, people are going to appreciate space more, I think, in 10 years' time.
Brilliant, thank you.
I'll take a stab at that, and I'll follow up by saying, to quote the UN Office for Outer Space Affairs Director, 60% of the indicators used to determine if the sustainability development goals are being achieved are space-based. Like all that data is coming from space. But in terms of in 10 years down the line, here's a slightly more hopefully optimistic note. I'm actually hoping that in 10 years, we're not just going to be getting data from space, but we're actually going to start seeing products being developed in microgravity that can't be developed here on Earth. There's a great company called Made in Space that has already, deployed, 3D printers on the International Space Station, and they're making fiber optic cables that are far faster and more efficient than anything we can make here on Earth, because microgravity is the difference. There's also more work being done on medicines and different types of biological work that is also being done in microgravity because of those unique characteristics. So my hope is that in 10 years, we're going to actually start seeing products being sold on the market, regular everyday things that enable us to be more efficient, to be faster, to have better lives here on Earth, but coming from a space manufacturing sector.
So just before we go on to the last answer, that's actually raised an interesting point about products, because I guess when you've got products coming from that sector, it's much easier to regulate any treaties with trade agreements, right? Because you can censor the trade between different countries coming from space. Then is that a possibility, do you think?
I mean, not necessarily. Like, it'll probably just still be, business is business. When you launch something into space, it's still a part of your country. So, if the United States has a private, if there's a private company that is located in the US, gets licensed by the US, they go up and they start producing something, they remain an American company under American jurisdiction. Sometimes one of my old colleagues also used to say, don't think about it as being special just because it's in space. These are all the activities that we're doing. It's just business as usual. It just so happens to be in a slightly more exotic location.
Brilliant, thank you. And Michelle?
So I'm going to, I'll just be very quick. So mine is a little bit of everybody's. So since COVID, I have spent an enormous amount of time with, top executives from very impressive companies who have been reevaluating their lives. And they have thought, I've always wanted to work in space. I wonder what that's like. So they reach out and they speak to people. Sometimes I'm one of those people. And I think we're getting a whole new caliber of professionals that are coming in to the industry that can create the kind of leadership that will bring the normality to doing business in space that we haven't seen yet. And the assimilation of, going to space is pretty normal. So I think that there is a lot more fidelity that can come from generating particular things in space that can create things that we've never even conceived of here. So I know that being in space in the next 10 years, I think that we're going to see some more really interesting products and just beliefs of how we should be conducting ourselves, both on Earth and in space. So that's what I hope. That's what I hope to see.
Brilliant. Thank you very much. I think we need to end it there, but that was a fantastic discussion and some really interesting points. Ray, so thank you all for joining. Much appreciated.
Thank you.
Thank you.
Ryan, do you have any
Thanks
last...
for having us.
No, that's fantastic.
Thanks very much.
I know we overran a little bit there, but we got into some fantastic discussions, and so I hope that was all okay with everyone. And thank you so much to all of our speakers, panelists, and of course SpaceBit as our sponsor for this event. And of course, as ever, thank you to Remco for your support with the SpaceUp Foundation. And of course, I should say thank you also to Ryan there, and yeah. So hopefully see you again shortly. So we haven't actually penned a date for the next event yet, but I mean, with it being we're still in COVID times, I think many events are still being held online. So we'll have a discussion to see about when to have another event. I'm sure, Remco, are you up for another event?
Absolutely, bring it on.
Yeah.
And I mean, it doesn't have to be us. Again, I'd like to open up the opportunity for everyone. That's really what SpaceUp is. We seem to be doing very well in organizing these events, but we're definitely not, this is not exclusive to us. So I'd like to invite anyone who's thinking of organizing an event like this, either virtual or whenever it's possible, wherever it's possible, in person, to consider organizing a SpaceUp event. But thank you, Ryan and Ryan, for again organizing a wonderful event with really, really valuable and wonderful speakers. And thank you to our speakers, and thank you to our audience.
Indeed. Thank you to everyone. And good night to some, and I guess it's not a night for some, so because it's a global event, which is great. But yes.
Good morning, good evening, and good night.
Yes.
Hey. Thank you. Bye, everyone.